What if I told you that there are planets out there where the sky rains glass and temperatures soar to unimaginable levels? Welcome to the universe's scariest places, where worlds like Proxima Centauri B and Trappist 1e challenge our understanding of life and survival. From the eerie depths of TRES 2b, the darkest exoplanet that absorbs almost all light, to the turbulent atmosphere of HD 189733b with its violent storms, join me as I take you on a journey to the scariest planets in the universe. Proxima Centauri B orbits the closest star to our solar system, which is known as Proxima Centauri. Despite lying within its star's habitable zone, where temperatures could allow for liquid water, the environmental conditions present numerous terrifying challenges for human exploration. The planet's atmosphere is shrouded in mystery, but scientists suggest that it may be thin, potentially unable to support life as we understand it. One significant concern is the relentless radiation from Proxima Centauri, a red dwarf star. Unlike our Sun, which has a stable and relatively moderate energy output, red dwarfs can be highly active, belching out powerful solar flares, which could strip away an atmosphere over time and expose the surface to harsh radiation levels. This places astronauts at a severe risk of radiation-related health issues, making prolonged stays on Proxima Centauri B incredibly dangerous without advanced protective technologies. Temperature variations also add to the grim outlook for future explorers. Proxima Centauri B is tidally locked, meaning one side constantly faces the star while the other remains in perpetual darkness. This creates extreme temperature differentials, with the day side potentially scorching hot, while the night side plunges into frigid conditions. Such extremes would pose significant challenges for human habitation and survival. Further complicating matters, little data exists about the planet's geological and atmospheric makeup. If Proxima Centauri B has a surface dominated by harsh terrain such as volcanoes, mountains, or deep valleys filled with toxic gases, the exploration would become not just terrifying but life-threatening. The uncertainty surrounding the conditions on Proxima Centauri B makes it clear that any journey to this distant world would be fraught with peril. Proxima Centauri B, located just over 4 light-years from Earth, orbits the closest star to our solar system, Proxima Centauri. This star is a red dwarf, and unlike our Sun, red dwarfs are known for their stellar activity. They can produce powerful flares and bursts of radiation, which can occur quite frequently. The proximity of Proxima Centauri B to its star places it closer to these potential dangers, raising questions about the habitability of this intriguing exoplanet. Being only about 105 million kilometers from Proxima Centauri, Proxima Centauri B lies well within the habitable zone. This is the region where conditions might allow for liquid water, a vital ingredient for life as we know it. However, the high level of stellar activity from its parent star could pose significant risks. Frequent solar flares could release bursts of high-energy particles, which could strip away the planet's atmosphere if it is not robust enough to withstand such relentless bombardment. A thin atmosphere may fail to provide the necessary protection against harmful radiation, making it challenging for life to survive. Moreover, red dwarfs like Proxima Centauri often exhibit strong magnetic fields, which can further amplify their activity. If Proxima Centauri B has a weak magnetic field of its own, it may be particularly vulnerable to these solar winds. The lack of sufficient shielding could lead to an environment more akin to a harsh and unstable radiation zone rather than a haven for life. On the other hand, if Proxima Centauri B has developed a strong magnetic field, it could deflect harmful radiation and preserve its atmosphere, creating a more favorable environment for life. As scientists continue to study the conditions on Proxima Centauri B, understanding the effects of its star on its potential habitability becomes imperative. The delicate balance between proximity to its parent star and the capacity of the planet to shield itself from solar events is crucial. This relationship may ultimately determine whether Proxima Centauri B is just another barren world or a hidden gem capable of supporting life, echoing the very characteristics that make our Earth such a unique oasis in the cosmos. TRAPPIST-1e, one of the intriguing planets in the TRAPPIST-1 system, presents a complex set of atmospheric conditions that could pose significant challenges for human habitation. While the planet exists in the habitable zone of its star, allowing for the possibility of liquid water, the atmosphere itself may not be as welcoming. Studies suggest that the atmosphere could be thick with gases such as carbon dioxide, or even contain ammonia, which can be toxic for humans. These gases can create an inhospitable environment where breathing becomes impossible without advanced life support systems. Moreover, the effect of stellar radiation is not to be underestimated. TRAPPIST-1 is an ultra-cool dwarf star that emits strong ultraviolet and X-ray radiation. This could result in a harsh surface environment, especially if the planet lacks a substantial magnetic field to protect it from cosmic rays and the star's radiation. Such exposure could lead to serious health risks for humans, including increased cancer rates and other radiation-related ailments. In addition to toxic gases and radiation, there are other potentially hazardous weather phenomena. If TRAPPIST-1e possesses a dense atmosphere, it could experience extreme weather conditions, such as fierce storms or intense heat waves. The constant temperature fluctuations might create unpredictable weather patterns, challenging agricultural practices essential for sustaining a human population. The potential for heavy cloud cover might also inhibit the growth of plant life upon which a human settlement would rely. Understanding TRAPPIST-1e's atmosphere emphasizes the delicate balance required for any extraterrestrial environment to support human life. It is not merely about having water and a suitable temperature. A breathable atmosphere, protective magnetic fields, and stable weather conditions are all critical elements. The study of such atmospheric conditions opens up new avenues for research and highlights the myriad complexities involved in searching for habitable worlds beyond our own. The planet TRAPPIST-1e has captured the imagination of scientists and space enthusiasts alike due to its location within the habitable zone of its star, a cool red dwarf named TRAPPIST-1. However, what may appear to be an inviting potential home at first glance presents formidable challenges when considering the extreme conditions on its surface. With temperatures that can swing to extremes, humans would have to contend with a climate that is both a concern for survival and a barrier to habitation. On TRAPPIST-1e, the temperatures are dictated by the proximity to the star, which is significantly cooler than our Sun. While its surface may allow for liquid water under specific conditions, the average temperatures could still reach scorching highs during the day due to a lack of atmosphere to regulate heat. Without sufficient atmospheric pressure and the right composition of gases, the thin air might not be able to support human life or any attempts at building sustainable habitats. Radiation levels on TRAPPIST-1e also amplify the challenges. The planet orbits a star that emits substantial levels of radiation, particularly in the form of ultraviolet light, which can be harmful to living organisms. Without a protective magnetic field or a significant atmosphere to provide shielding, any human presence would be at risk of radiation exposure that can lead to acute health effects. These include severe burns or long-term consequences, such as increased cancer risk and damage to vital organs. Ultimately, thriving on TRAPPIST-1e would require advanced technology and infrastructure designed to combat the fierce temperatures and high radiation levels. Developing habitats that incorporate shielding materials, efficient cooling systems, and life support functions becomes crucial for any serious consideration of human colonization. The quest for survival, therefore, transforms TRAPPIST-1e from a promising candidate for extraterrestrial life into a complex environment filled with obstacles that must be carefully navigated. TRES-2 b, an exoplanet situated approximately 40 light-years away from Earth, is famed for its astonishingly dark surface. Unlike other celestial bodies that reflect sunlight, TRES-2 b absorbs nearly 99% of the light that strikes it. This extreme darkness arises from the thick, gaseous atmosphere composed primarily of sodium and potassium clouds, which acts like a shroud, preventing light from bouncing back into space. This characteristic not only makes it one of the darkest known exoplanets, but also triggers curiosity about its atmospheric conditions and potential chemical processes. The psychological impact of such profound darkness on human explorers could be significant. Imagine standing on a world where the concept of brightness is virtually non-existent. The perpetual twilight created by the light-absorbing surface would create unique challenges for researchers accustomed to the luminosity of Earth. Limited visibility could lead to feelings of disorientation and anxiety, as darkness often evokes a sense of the unknown and can trigger psychological discomfort. This effect might deepen if explorers were affected by the isolation of being on an alien world far from home. Furthermore, the absence of light could resonate with deeper fears embedded within human psychology. Darkness can often symbolize the unknown, leading to heightened senses of vulnerability. This aspect could be amplified on TRES 2b, where the explorers would not only be dealing with the planet's inherent darkness, but also the realization that they are light years away from familiar comforts and safety. Such an environment might promote intense introspection and foster a unique camaraderie among crew members as they share the only source of warmth and light within their shared habitat. The journey to adapt to the darkness would require human explorers to develop innovative coping strategies and technologies. This might include creating artificial light sources or depending on their own advanced navigation tools to find their way around. Ultimately, the experience of navigating the darkness of TRES 2b would not be just a scientific challenge, but also a deeply psychological expedition, testing the resilience of human spirit in the face of the vast cosmic unknown. TRES 2b, a planet located approximately 40 light-years away from Earth, presents an incredibly challenging environment for potential human colonization. The extreme heat on this exoplanet is unlike anything we encounter on Earth. With surface temperatures soaring higher than 1,000 degrees Fahrenheit, TRES 2b's conditions are often compared to those found near the hottest stars. This searing heat results from the planet's close proximity to its host star, which is a type of K-dwarf. Unlike our Sun, this star emits a considerable amount of infrared radiation, bathing TRES 2b in relentless warmth without respite. Adding to the challenge is the significant lack of light. Although TRES 2b is tidally locked, meaning one side faces its star perpetually while the other remains in darkness, the illuminated side is a blistering desert. The darkness may allow for cooler conditions, but the absence of light presents challenges for harnessing energy through conventional solar means. Without adequate light, the prospect of growing food or generating energy becomes far more complex. For any attempt at human settlement, advanced technology would be essential to combat these extreme conditions. Human habitats would need to be carefully designed to withstand overwhelming heat, incorporate powerful cooling systems, and possibly utilize geothermal or even nuclear energy sources to maintain a livable environment. Additionally, securing a sustainable food supply would require innovative agricultural methods, such as controlled environment farming, which could shield crops from the harsh conditions. Even with these technological advancements, the extreme climate of TRES 2b raises critical questions about long-term sustainability. Establishing a self-sufficient colony could be an ongoing struggle, requiring constant adaptation and the ability to recover from potential failures. The dream of reaching and colonizing new worlds is enticing, but TRES 2b serves as a stark reminder of the formidable obstacles that lay ahead in our quest to explore and inhabit the universe. Kepler 10b, an exoplanet located approximately 21 million light-years away, presents an extreme environment that would be utterly incompatible with human life. This rocky planet orbits its star at a remarkably close distance, leading to surface temperatures that soar over 1,000 degrees Celsius. Such intense heat transforms the landscape into a furnace-like atmosphere where even metals could melt. Human beings require specific conditions to survive, and the blistering temperatures on Kepler 10b far exceed the limits of our biology. Our bodies rely on a delicate balance of temperature and pressure to function properly. When temperatures reach the scale found on Kepler 10b, there would be no chance for water to exist in any stable form, since it would instantly vaporize. The vital necessity of liquid water for life is non-negotiable, and without it, the very foundation of life as we know it crumbles. Furthermore, the atmospheric conditions on Kepler 10b are likely to be oppressive. The planet's proximity to its star implies a strong gravitational pull and intense radiation, which further complicates the possibility of any protective atmosphere. Human organisms require breathable air rich in oxygen to survive, and it is likely that any atmosphere on Kepler 10b would lack this essential element, instead being composed of harmful gases that would pose serious threats to any potential life forms. The combination of lethal temperatures, the absence of liquid water, and a potentially hostile atmosphere creates an environment on Kepler 10b that would be devastating for human life. The challenges inherent in such extreme conditions serve as a reminder of how finely tuned our own planet is for sustaining life. Human exploration of other planets is intricately intertwined with the composition of their rocks and the gravitational forces present. Each planet has its own unique geological structure, which can influence not only surface conditions but also the way landers and rovers operate once they arrive. For instance, some planetary surfaces are dominated by fine dust, creating challenges for mobility as vehicles can become bogged down or struggle to gain traction. Others might feature jagged rocks and boulders that pose significant risks to exploratory crafts attempting to navigate the terrain. Gravitational forces play a crucial role in shaping these environments. On planets with weaker gravity, such as Mars, spacecraft experience less gravitational pull when landing. While this might seem advantageous, it can complicate the landing process since less gravitational force makes it difficult to gauge descent speed and impacts the potential for bouncing. Conversely, on planets with stronger gravity like Jupiter, the challenges multiply, as any landing attempt would require immense energy and robust designs to withstand the increased force exerted upon descent. Moreover, the chemical makeup of a planet's rocks can pose risks to human exploration efforts. For instance, the presence of certain minerals could mean exposure to toxic elements upon disturbance, presenting a health hazard to astronauts. Additionally, the interactions between varying rock compositions and the equipment humans use could lead to unforeseen reactions, causing malfunctions or damage to essential machinery. Lastly, the unpredictability of the geological activity adds another layer of complexity. Volcanic eruptions, landslides, or even seismic activities can create hazardous conditions, potentially jeopardizing missions. Thoroughly understanding these rock compositions and gravitational effects is crucial for ensuring that human explorers can traverse other worlds safely and effectively, paving the way for future discoveries in our solar system. HD 189733b is a planetary marvel that challenges our understanding of extreme weather. This exoplanet, located approximately 60 light-years away from Earth, exhibits conditions that can only be described as hostile. The most striking feature of this world is its violent storms, where winds howl at speeds reaching up to 2,000 miles per hour. That is over 800 times faster than the strongest winds recorded during a hurricane here on Earth. The atmospheric conditions can be as shocking as the wind speeds themselves. The skies of HD 189733b are laced with glass rain, resulting from the planet's unique combination of temperature and pressure. This glass, composed of silicate materials, can slice through the atmosphere at incredible speeds, turning this downpour into a deadly spectacle. Imagine standing in a storm where the precipitation is not only relentless, but also sharp enough to cause severe damage. Temperature variations also contribute to its menacing weather. The dayside of HD 189733b reaches scorching temperatures around 2,000 degrees Fahrenheit, while the nightside plummets to significantly lower levels. This dramatic shift creates intense thermal currents in the atmosphere, leading to unpredictable weather patterns. The interaction between the hot and cold regions generates turbulent winds and chaotic storms, making this planet a relentless whirlwind of destruction. In this tumultuous atmosphere, clouds of iron and molten glass condense and exist concurrently, forming a bizarre and deadly environment. The combination of high-pressure systems and extreme heat results in colossal storms that dwarf anything humanity has witnessed. HD 189733b serves as a stark reminder of the universe's capacity for creating worlds that defy our imagination and offer severe challenges for potential exploration. The immense storms and extreme conditions present on other planets create significant challenges for any potential human visitors. For example, the atmosphere of planets like Jupiter and Saturn is filled with fierce storms that can last for centuries. Wind speeds can reach incredible levels, often exceeding several hundred miles per hour. Such powerful winds can damage spacecraft and pose a severe threat to the safety of astronauts who may find themselves exposed to these erratic conditions. Extreme temperatures also play a formidable role. On the surface of these gas giants, the conditions can vary dramatically, from searing heat to bone-chilling cold, depending on the depth within the atmosphere. If humans were to venture into these environments, they would face the risk of equipment failure due to the intense pressures and temperature fluctuations. Specialized technology would be necessary to withstand these drastic changes, making the idea of crewed missions far more complex and complicated. Furthermore, the composition of the atmospheric gases itself raises concerns. Many of these planets possess thick clouds of ammonia and methane, gases that are toxic to humans. The prospect of visitors navigating through such environments would require highly advanced life support systems to provide breathable air and protect against harmful substances. This means developing habitats that could endure the storms while ensuring a safe and habitable environment for crew members. Exploring other planets involves not just the excitement of discovery, but also prudent consideration of these hostile elements. As humanity looks toward the stars, the understanding of these extreme planetary conditions will be crucial. Safeguards must be meticulously planned and carefully engineered to address the myriad dangers inherent in the exploration of our solar system's most extreme worlds. WASP 121b is an extraordinary exoplanet, showcasing extreme conditions that make it a true outlier in planetary science. Located about 800 light-years away in the constellation Puppis, this gas giant orbits so close to its star that temperatures soar to astonishing levels, often exceeding 1,500 degrees Celsius. Under such intense heat, elements that are typically solid at lower temperatures, like metals, exist in a molten state. This unusual atmospheric phenomenon creates a hostile environment that poses severe challenges for any potential human exploration. The molten metals present in the atmosphere of WASP 121b, including iron, create not just an inhospitable climate, but also significant safety concerns. As these metals vaporize, they contribute to a thick and toxic atmosphere filled with metallic vapors. Such conditions would be lethal to humans, as the corrosive nature of these materials could easily damage any protective gear. The constant bombardment of molten droplets means that even the most advanced technology would struggle to maintain its integrity, risking catastrophic failures. Additionally, the extreme temperature fluctuations that occur on WASP 121b further complicate the matter. The planet experiences blistering heat on the side facing its star, while the opposite side could be significantly cooler. For explorers, navigating this disparity would involve tremendous risks, including severe thermal shock, which could impede critical life support systems in a human habitat. The molten metallic presence not only amplifies the risks associated with temperature, but also intensifies the challenges of radiation exposure from the nearby star. Ultimately, these factors combine to shape a perilous landscape around WASP 121b. The dangers posed by molten metals, coupled with extreme temperatures and toxic vapors, underscore the difficulty of envisioning any form of human exploration. While the planet ignites our curiosity about the universe's extremes, it also serves as a reminder of the monumental obstacles that lie between humanity and the stars, exemplifying the harsh realities of space beyond our home planet. Astronauts exposed to the extreme conditions of a planet like WASP 121b could experience significant psychological challenges. The sight of temperatures soaring above 1,700 degrees Fahrenheit, along with the planet's atmospheric phenomena, could evoke feelings of isolation and vulnerability. Witnessing such an inhospitable environment might serve as a harsh reminder of their own fragility in the universe. This scenario could instigate fear as the astronauts realize the stark realities of space and the limits of human endurance. The loneliness of space travel is already a well-documented aspect of long missions. Experiencing the extreme weather of another world, from boiling temperatures to potentially violent storms, could exacerbate feelings of separation from Earth and loved ones. The relentless exposure to these extreme conditions might lead to a sense of helplessness, as astronauts would have to confront constants that are beyond their control. Over time, the stress of such a stark and dangerous environment could contribute to conditions like anxiety or depression. In addition to fear and anxiety, there may also be a profound sense of awe or existential reflection. Observing the harsh realities of WASP 121b could lead to an appreciation for the resilience of life on Earth. The contrast between the lush landscapes of our planet and the violent features of this distant world could foster deeper thoughts about civilization, survival, and the uniqueness of human existence in the cosmos. Such reflections could stimulate philosophical discussions among crew members, yet they might also bring feelings of insignificance in the grand scale of the universe. Furthermore, the psychological effects may vary among individuals based on their personal experiences and coping mechanisms. Some may find motivation in the quest for knowledge, while others could struggle under the weight of what they witness. This variability highlights the importance of mental preparation and support systems for astronauts embarking on such exploratory missions. As we continue to explore our universe, understanding the psychological implications of these endeavors will be vital to ensuring astronauts are equipped to face the unknown both physically and emotionally. The exoplanet known as 55 Cancri E offers a striking glimpse into a world shaped by extreme volcanic activity. With its surface characterized by vast lava fields and molten rock, any human encounter would likely face severe hazards. The intense heat generated by this volcanic activity reaches remarkable temperatures, making it one of the hottest planets discovered so far. Conditions on 55 Cancri E could create a deadly environment for humans unprepared for the extreme thermal challenges. The atmosphere of this planet further complicates any potential exploration efforts. It is believed to be thick with exotic materials, possibly including vaporized rock and a variety of gases released from frequent eruptions. These gases could be toxic, creating an inhospitable breathing environment. Even if suitable protective equipment could be developed to withstand the heat, the presence of hazardous gases would require sophisticated filtration systems that might not yet exist. Moreover, the constant volcanic eruptions can lead to erratic geological activity. This unpredictability poses a significant risk for space missions. Gas explosions and flowing lava could alter landscapes swiftly, making it difficult for explorers to navigate safely. Any structures or equipment deployed on the surface would have to withstand not only the extreme temperatures, but also the shocks of nearby volcanic events, which could destabilize habitats or research stations. Ultimately, while the prospect of studying 55 Cancri E is undeniably thrilling, the challenges presented by its volcanic nature highlight the dangers of engaging with such alien environments. Each exploration of other worlds teaches us about the inhospitable conditions that could greet human beings, reminding us of the barriers yet to be overcome in the quest to explore the cosmos. The risk of seismic events presents significant challenges to exploration missions, particularly those taking place in regions known for their geological activity. Earthquakes and volcanic eruptions can occur suddenly and unpredictably, potentially endangering both crewed and uncrewed vehicles. These geological phenomena may cause severe ground shaking, landslides, or volcanic ash clouds, which can disrupt launch and landing operations or hinder critical scientific investigations. Safety protocols must be adopted for exploration missions, particularly in areas such as California or Japan, where tectonic plates frequently interact. Mission planners devise intricate strategies that account for seismic risks, determining safe zones for research bases, and ensuring that equipment is resilient against potential damage. Engineers meticulously design spacecraft and landers to withstand unexpected geological forces. This design necessity ensures that even if seismic activity occurs, the integrity of the mission is maintained, thereby protecting the equipment and the scientists on board. Additionally, seismic monitoring systems play a crucial role in enhancing safety during missions. These systems detect ground movement and can provide early warning signals of an impending seismic event, allowing for precautionary measures to be enacted. Such measures might involve relocating personnel or safeguarding sensitive equipment to minimize exposure to the unforeseen dangers posed by these natural events. Exploration in seismically active areas offers both remarkable opportunities and substantial risks. Exploration in seismically active areas offers both remarkable opportunities and substantial risks. The potential for groundbreaking discoveries in these regions must be carefully weighed against the challenges posed by geological instability. Ultimately, the ability to adapt and respond to the threat of seismic events not only safeguards exploratory missions, but also deepens our understanding of the forces shaping our planet. Visiting an exoplanet like 55 Cancri E, well known for its extreme time dilation due to its unique orbit and gravitational influences, could lead to profound psychological effects on human visitors. Time dilation occurs when an object moves at a significant fraction of the speed of light or is subjected to strong gravitational fields. In the case of 55 Cancri E, its proximity to its host star results in a fascinating but challenging scenario where time can behave quite differently compared to life on Earth. As travelers experience varying rates of time passage, they might feel a disconnection from the people and world they left behind. The potential difference in time could mean that while mere months pass for them, years could elapse on Earth. This discrepancy could foster feelings of isolation and anxiety, as relationships with family and friends can become strained or entirely altered during their absence. The notion of returning to a changed world can weigh heavily on the psyche, introducing stress and uncertainty. Moreover, the sensation of time traveling differently can alter a visitor's perception of reality. As they witness the revolving environments of their distant home contrasted against their own temporal experience, they might grapple with existential questions about their identity and purpose. The realization that life on Earth continues without them could lead to feelings of insignificance or melancholy. These emotional responses could be intensified when returning home, reintegrating into a society that has fundamentally changed. Then there are the possibilities of perceived time manipulation during their stay on the planet itself. Visitors might find their experiences distorted. Moments could feel either elongated or fleeting based on their altered perception of time. Such fluctuations can lead to cognitive dissonance as they reconcile their experiences with a timeline that no longer aligns with earthly existence. In confronting these mental and emotional challenges, space explorers would require not just physical preparation, but also robust psychological support to navigate the profound effects of time dilation during their extraordinary journey. The potential presence of lava oceans on other celestial bodies, such as some moons of Jupiter and Saturn, presents intriguing challenges for human survival equipment. When considering environments with temperatures reaching thousands of degrees Fahrenheit and the fluid nature of molten rock, standard materials used in past space missions would prove insufficient. High-performance materials capable of withstanding extreme temperatures and corrosive environments must be developed to ensure the safety of astronauts. Moreover, the challenge extends beyond the materials themselves. The design of equipment also requires innovation. Traditional tools and implements might malfunction or degrade upon exposure to such harsh conditions. For instance, life support systems that rely on standard atmospheric interactions may become inoperable. This necessitates advanced engineering solutions that allow for heat-resistant thermal barriers and robust sealing mechanisms to protect critical systems from the intense heat and the possible gases emitted from lava oceans. Additionally, navigation and mobility would be severely affected in such extreme landscapes. Engineers and scientists must rethink how vehicles, habitats, and exploration suits can operate effectively on or near these fluid lava surfaces. The risk of sudden eruptions or shifts in molten rock complicates movement and requires advanced safety protocols and monitoring systems to protect personnel from unexpected hazards. As we explore the cosmos, addressing these challenges not only pushes the boundaries of our technological capabilities, but also deepens our understanding of how humans can adapt to the most extreme environments. The possibility of encountering lava oceans reminds us of the ingenuity needed to traverse and ultimately thrive on worlds vastly different from our own, ensuring that human presence in space can extend far beyond the confines of Earth. Gliese 436b presents an extraordinary case in our search for extraterrestrial worlds. This exoplanet, located approximately 32 light-years from Earth, is classified as a hot Neptune due to its icy and rocky composition, while also possessing a thick atmosphere. What makes this environment so puzzling and indeed unsettling for scientists is its unusual combination of high temperatures and pressures, which creates conditions unlike any we experience on Earth. One of the most striking features of Gliese 436b is its water. Unlike the liquid form we are accustomed to, the immense pressure on this planet causes water vapor to exist within a state that is dense and smoky, making it denser than any liquid form we know. This leads to the creation of exotic states of matter, such as supersonic water, where the oxygen molecules become locked in a crystalline structure while the hydrogen ions flow freely. This phenomenon raises alarm among researchers as it challenges our fundamental understanding of why and how substances phase into different states under extreme conditions. Moreover, scientists are troubled by the planet's gravitational pull, which is approximately 1.5 times that of Earth's gravity. This increased force could have profound effects on any potential atmospheres and surface conditions. The result is a world of extreme atmospheric dynamics, where high-speed winds could stabilize or disrupt the outer layers of the atmosphere, leading to unpredictable weather patterns that are difficult to model. With such dynamic and violent atmospheric behavior, the very fabric of the planet's environment remains shrouded in mystery. This exoplanet embodies the complexities and extremes of planetary formation and evolution beyond our solar system. The more researchers study Gliese 436b, the clearer it becomes that our knowledge of the universe is still in its infancy. Every peculiar characteristic invites further exploration and scrutiny, raising questions about the formation of such planets and what it might ultimately reveal about the cosmos. The challenges posed by these strange traits only serve to fuel the excitement and curiosity within the scientific community as they strive to decode the secrets of Gliese 436b. The extreme density of a planet can create challenging and even unsettling conditions for explorers attempting to navigate its surface. If we consider a body such as Jupiter, which is known for its considerable density, the weight of the atmosphere is immense. This high-pressure atmosphere results in gravity that is much stronger than what we experience on Earth. For an explorer accustomed to walking in our environment, taking steps on such a planet could feel entirely foreign and disorienting. This increased gravitational pull would not only make mobility taxing, but it would also affect the human body. Prolonged exposure to such strong gravity could lead to discomfort, fatigue, and even serious health risks. As explorers attempt to move, their body would struggle to adapt to the oppressive weight, potentially resulting in claustrophobic feelings and a sense of being crushed by the environment itself. The very act of walking could be a test of endurance, leading to an unsettling experience as their muscles and bones strain against forces they were not designed to handle. Moreover, the dense atmosphere would pose additional hazards. On planets with thick clouds composed of ammonia and methane, explorers would have to face not only the physical challenge of their environment, but also the chemical dangers. This combination of high pressure, thick atmosphere, and low visibility could contribute to feelings of isolation and fear. Simply navigating from one location to another could turn into a harrowing journey, where the terrain becomes unpredictable and the atmosphere a constant reminder of their vulnerability. Compounding these factors, the sensory overload created by the planet's unusual gravitational and atmospheric conditions could disorient explorers even further. The sounds, pressures, and potential weather phenomena unique to a dense planet would permeate their experience. The entirety of their visit would become an exercise in adaptation and resilience, a stark reminder of the bewildering complexities of planetary exploration in environments so different from our own. The absence of a significant atmosphere on LHS 3844b poses distinct challenges and hazards for any exploration efforts. Without a protective layer of gases, this exoplanet does not offer the shielding typically provided by atmospheres against cosmic radiation and solar winds. This increased exposure can damage equipment and pose serious health risks to any potential human explorers, as harmful radiation could penetrate habitats and spacesuits alike. Moreover, the lack of atmospheric pressure means that any surface water, if it exists, would rapidly evaporate or freeze, depending on the temperatures. This creates a harsh and inhospitable environment, where the potential for life as we know it is significantly diminished. Instruments designed for exploration would need to be specially crafted to withstand the extreme conditions, such as temperature fluctuations and a lack of thermal insulation, which makes such missions more complex and costly. Another consideration is the challenge of landing on and traversing the planet's surface. Without an atmosphere to provide aerodynamic resistance, traditional spacecraft landing techniques, which rely on parachutes or atmospheric drag, would be ineffective. This could lead to high-velocity impacts or necessitate the development of entirely new landing systems capable of descending safely onto the planet's surface. The hostile elements of LHS 3844b present not only technological challenges, but also require extensive preparation and planning to ensure the safety and success of exploratory missions. Understanding these hazards is crucial for future missions that aim to unveil the mysteries of such distant worlds. The planet LHS 3844b presents an extraordinary case in the study of exoplanets, particularly with its extreme temperature fluctuations. This rocky world, located approximately 250 light-years away from Earth, experiences intense heating during its day, reaching temperatures exceeding 1,000 degrees Celsius. When night falls, the temperatures can plummet dramatically, dropping to near absolute zero. Such severe shifts in temperature are unprecedented for human habitability and present unique challenges for adaptation. To illustrate the significant difficulty of adjusting to these conditions, consider that human physiology is finely tuned to a relatively narrow range of temperatures. Humans thrive best in environments where air temperatures are comfortable, allowing for efficient bodily functions. The drastic thermal swings on LHS 3844b would likely require not just new technologies, but also a complete rethinking of habitation strategies. Protective habitats would need to be self-regulated and insulated to cope with such extremes, akin to creating mini-environments within a hostile landscape. Furthermore, the psychological effects of such a harsh environment cannot be overlooked. Communities might struggle with isolation, the stark differences between day and night, and the potential for solar radiation exposure during the daytime. Even technologically advanced life support systems would be put to the test, needing to manage constant extremes to ensure survival. This emphasizes the complexity of adapting to a world where the very conditions of existence challenge our inherent biological limits. Exploring LHS 3844b, therefore, is more than just scientific curiosity. It raises fundamental questions about what it means to be human in an alien environment. While our capacity for innovation is vast, the thought of confronting radical climates beyond our planet's nurturing embrace highlights the innate fragility of life as we know it. The pursuit of adapting to such worlds not only deepens our understanding of the universe, but also prompts us to reflect on the resilience and limitations of human beings in the face of the cosmos. The planet Kepler 13b, located in the constellation Cygnus, presents an awe-inspiring yet terrifying picture of what awaits in the cosmos. As scientists analyze data from this distant world, they uncover immense storms and tumultuous cloud patterns that stretch over its surface. With atmospheric conditions marked by extreme temperatures often exceeding 2,000 degrees Fahrenheit, these storms reach magnitudes that dwarf anything experienced on Earth. The swirling clouds, composed primarily of vaporized minerals, create a volatile environment, shrouded in the profound uncertainty of what lies beneath the tumult. Visualizing these chaotic weather patterns evokes a palpable sense of dread when considering potential exploration. The fierce winds that can reach speeds close to the sound barrier raise significant challenges for spacecraft design and durability. Missions aimed at understanding this alien atmosphere would require technology that can withstand both the relentless pressure and the scorching heat. The sheer scale of these storms hints at a level of unpredictability that could jeopardize even the most advanced exploratory craft. Moreover, the atmospheric composition adds another layer of fear. The presence of metallic clouds, formed by minerals such as iron and titanium, suggests that the storms not only rage fiercely, but could also be dangerously corrosive. This aggressiveness can result in an almost violent interaction between the planet's environment and any technology attempting to delve deeper into its mysteries. These factors combine to paint an unsettling picture of what human exploration would truly entail. As researchers project the potential for future missions to Kepler 13b, they cannot help but reflect on the lessons learned from our own planet's extreme weather events. The combination of immense heat, relentless storms, and corrosive compounds encapsulates a key lesson in humility. The pursuit of knowledge about such worlds prompts a contemplation of our limitations and the inherent risks of venturing into the unknown, shaping the future of exploration in profound ways. Kepler 13b presents an extraordinary example of an exoplanet, where conditions differ dramatically from those on Earth. This planet orbits its host star at an incredibly close proximity, resulting in extreme gravitational forces that are more than twice that of Earth. So, how might such intense gravity influence human physiology should we ever find ourselves living there? First and foremost, the human body relies on gravity to maintain its structure and function. In environments with lower gravity, such as the International Space Station, the body experiences muscle atrophy and bone density loss over time. Conversely, on Kepler 13b, the intense gravitational pull would place immense strain on our skeletal system and muscular structure. The human frame is designed to withstand Earth's gravity, but doubling that force would challenge our bones and muscles to process this weight effectively, leading to potential fatigue and stress fractures. Moreover, the cardiovascular system would face significant challenges in this high-gravity environment. The heart, which works tirelessly to pump blood throughout the body, would encounter additional demands as it must work harder to circulate blood against this stronger gravitational force. This could result in elevated blood pressure and increased risk of cardiovascular issues over extended periods. This would necessitate groundbreaking advances in medicine and human adaptation strategies, illuminating the resilience of the human spirit when faced with the laws of physics on distant worlds. The discovery of high-energy radiation emissions from GJ 3470b raises significant concerns about the potential hazards it poses to human life. This exoplanet, located about 21 light-years away in the constellation Capricornus, has become a focal point for astronomers studying exoplanetary environments. The intense radiation it emits could have profound implications for the conditions on and around the planet. High-energy radiation, which includes X-rays and gamma rays, can be detrimental to biological organisms. On Earth, the atmosphere provides a protective shield against such radiation, allowing life to thrive. However, GJ 3470b orbits its host star, a red dwarf, at an extremely close distance. This proximity likely results in increased exposure to harmful radiation. If a planet or moon were to harbor life in such an environment, it would need robust protective mechanisms, potentially including thick atmospheres or magnetic fields, to counteract the effects of this radiation. Moreover, the emissions from GJ 3470b may impact not just the planet itself, but also its atmosphere. High-energy radiation can contribute to atmospheric stripping. a process where particles are ejected from the atmosphere into space. This can significantly diminish the chances of maintaining a stable environment for any potential life forms. The interactions between this radiation and the planet's atmosphere are crucial, as they can determine whether conditions could be hospitable or utterly inhospitable. In exploring the potential for human exploration or colonization, these radiation levels present substantial challenges. Any missions aiming to reach GJ 3470b or study it closely would need to take extensive precautions against radiation exposure. With all these factors considered, the high-energy emissions from this intriguing exoplanet remind us that the universe can be as perilous as it is fascinating. The proximity of a planet to its host star can lead to extreme temperatures that present significant challenges for any exploration efforts. When a planet orbits very close to its star, it tends to experience intense and prolonged exposure to stellar radiation. This contributes to surfaces that can reach scorching temperatures. For instance, on an imaginary planet orbiting a star similar to our Sun, the conditions could be so severe that the surface becomes molten, rendering exploration equipment and human missions infeasible. Dangerous heat waves could also dramatically influence the planet's atmosphere, possibly leading to the creation of hostile weather patterns. If the atmosphere contains significant amounts of gases, these gases might become superheated, resulting in violent storms and unpredictable thermal fluctuations. Such conditions not only complicate any exploratory efforts, but also pose serious risks to the safety of crewed missions, which would need to withstand such extreme elements. Furthermore, temperature variations could impact the technology used in exploration. Instruments designed to operate under specific temperature ranges may fail or become less effective if exposed to heat waves that exceed their capacities. Persistent high temperatures can warp materials, alter electronic systems, and degrade structural integrity. Explorers would have to develop advanced technology that can endure these extreme conditions, which adds complexity and cost to space missions. Ultimately, the dangerous heat waves resulting from a close orbit pose multifaceted challenges for explorations, requiring innovative solutions to ensure the safety and success of missions while revealing the secrets of these hostile worlds. The quest for knowledge continues to push the boundaries of our capabilities, even when faced with such formidable hurdles. Kelt 9b is nothing short of an astronomical enigma, captivating the attention of astronomers with its extreme characteristics. Located about 175 light-years away in the constellation Cygnus, this exoplanet holds the distinction of being the hottest known exoplanet, orbiting its star at breakneck speeds. The temperatures on this gas giant can soar to approximately 4,300 degrees Celsius, a scorching heat that far exceeds that of molten lava. The extreme thermal environment of Kelt 9b prompts fascinating scientific explorations. With such high temperatures, the planet's atmosphere is likely to be a bizarre mixture of elements and compounds that defy our typical understanding of planetary environments. For instance, sodium and potassium may exist in gaseous forms within the atmosphere, providing a unique opportunity for astronomers to study these elements in such dynamic settings. This presents a thrilling chance to observe how atmospheres behave under conditions that do not exist within our own solar system. The photonic traits of Kelt 9b further enhance its uncanny appeal. As it orbits its host star, the intense light and energy from that star contribute to the complicated atmospheric phenomena detectable from afar. The planet's atmosphere might also exhibit exciting chemical dynamics, like possibly developing clouds or even having chemical reactions fueled by the high-energy photons emitted by its host star. Such characteristics raise intriguing questions about the potential for weather patterns and chemical processes that could reshape our understanding of exoplanetary atmospheres. In addition to the challenges Kelt 9b presents for observational astronomy, it also compels scientists to rethink theories about planet formation and evolution. This mesmerizing exoplanet, with its combination of extreme heat and unique photonic interactions, serves as a reminder of the vast and surprising diversity of worlds in our universe, inviting both fascination and deep scientific inquiry into the nature of planetary systems beyond our own. Analyzing the atmosphere of a planet with extreme conditions presents numerous challenges and potential dangers. When scientists turn their attention to planets with harsh environments, such as those with suffocating heat, intense pressure, or corrosive gases, they find that the equipment and methods used for exploration must be incredibly robust. For instance, planets like Venus, which boasts surface temperatures hot enough to melt lead, pose significant risks to any spacecraft intended for study. The materials that are typically used in space probes might not withstand such extreme heat for long periods, leading to quick degradation or failure. In addition to heat, the atmospheric composition is often a concern. Some planets have environments with thick clouds made up of toxic gases or heavy acids that can corrode instruments. A probe attempting to collect data in such an atmosphere could face the risk of being damaged before it even has a chance to send back important findings. The corrosive nature of these atmospheres can render instruments inoperable, limiting the data collected and impeding our understanding of these alien worlds. Another danger arises in the unpredictable weather patterns that can exist in these harsh atmospheres. For example, the planet Jupiter is known for its violent storms, including massive cyclones. Sending a probe into the center of such a storm could end in disastrous consequences for both the machinery and the mission itself. The sheer power of the winds and the tumultuous movement of gases can expose equipment to conditions beyond its design limits. Beyond equipment failure, there are also implications for the safety of human missions. In the future, if humanity aims to send astronauts to explore or even settle on these extreme planets, the challenges multiply. Adequate shielding from temperatures, poison, and atmospheric pressure will be necessary to ensure the health and safety of any crew involved. Each of these factors underlines the complexity and unpredictability of exploring planets with extreme atmospheric conditions, showcasing both the dangers and the potential for groundbreaking discoveries in our quest to understand the universe. HAT P7b, a giant exoplanet located approximately 1,000 light-years away in the constellation Cygnus, presents some truly extreme weather conditions. This exoplanet is a gas giant, and it orbits very close to its parent star, resulting in surface temperatures that can soar to unprecedented levels. These scorching temperatures give rise to conditions that include fiercely strong winds and potentially planet-wide storms, similar to what we might imagine with hurricanes, but on a much grander scale. Such violent weather patterns create an environment that would be utterly inhospitable to human life. The temperature variations on HAT P7b can lead to extreme climatic phenomena. One side of the planet is perpetually scorched by its star, while the other remains in complete darkness. This stark contrast can generate intense heat storms, with winds that are estimated to reach speeds far greater than those of Earth's most violent tornadoes. For humans, the implications of experiencing such relentless and volatile weather would be catastrophic. Survival would be nearly impossible without advanced shelter and protection. Any attempt to explore or even observe HAT P7b would necessitate technology far beyond what we currently possess. Moreover, the atmospheric composition of HAT P7b adds another layer of risk. The presence of clouds composed of molten rubies and sapphires has been detected, hinting at an atmosphere rich in various gases that could be toxic for human beings. Picture trying to breathe under the choking haze of an atmosphere that is not only unwelcoming, but actively harmful. Without specialized life support systems, exploring HAT P7b would not only be treacherous, but also potentially fatal. In contemplating the future of space exploration, HAT P7b serves as a stark reminder of the challenges humanity faces when encountering the unpredictable and often harsh environments of alien worlds. The extreme weather conditions observed on this distant planet underscore the vast differences between our hospitable Earth and the inhospitable realms of the cosmos. Understanding the effects of a planet's unique orbit gives us insights into the delicate balance of its atmosphere. Our own Earth completes one full revolution around the Sun each year, but other planets experience very different scenarios. For instance, some planets have elliptical orbits that bring them closer to the Sun at certain times, leading to significant shifts in temperature. This proximity can swiftly heat the atmosphere, causing drastic changes in weather and climate patterns. Consider the case of a planet like Mercury. It has a highly elliptical orbit which results in substantial temperature variations between day and night. Daytime temperatures soar while nights plunge to severe lows. Such extremes can lead to atmospheric escape, where lighter molecules are propelled into space under intense conditions. This loss can be devastating for any potential life forms that rely on a stable atmosphere. In addition, the axial tilt of a planet plays a pivotal role in its atmospheric dynamics. If a planet's tilt is significant, it means that different regions receive varying amounts of sunlight throughout its orbit. This uneven heat distribution can lead to violent storms, contributing to an unstable atmosphere. For planets with enough gravity to hold onto thick atmospheres, rapid shifts can lead to extreme weather patterns that could easily become lethal for any inhabitant. Moreover, these rapid changes in atmospheric conditions have broader implications. The increased temperatures can trigger feedback loops that further destabilize climates. For example, as ice melts, less sunlight is reflected away, which leads to even more warming. If a planet's orbit fluctuates dramatically, the survival of any future ecosystems and potential life could be jeopardized by the very climate shifts that result from such an orbit. Luyten B, an exoplanet located in the habitable zone of its star, presents some concerning factors when it comes to the viability of human habitation. Its surface conditions raise alarms primarily due to the planet's likely harsh environmental qualities. For one, being a tidally locked world, one side of Luyten B faces its star perpetually, creating extreme temperature disparities. The sunlit side could be searingly hot, while the dark side might be frigid beyond what humans can endure. Such dramatic shifts complicate the potential for stable, comfortable habitats. Moreover, the atmosphere of Luyten B is a critical concern. If it possesses a thin or toxic atmosphere, which some scientists speculate, this may not provide the necessary protection against cosmic radiation. Any significant radiation exposure could be harmful to human health, especially over extended periods. Without a robust atmosphere to shield against solar and cosmic rays, the risks increase substantially for long-term occupants. Additionally, the geological activity of Luyten B presents its own challenges. Planets in similar systems often exhibit volcanic activity or seismic events. Such unpredictable geological phenomena could pose threats to structures built for human habitation and create a perilous situation for settlers. Any eruptions or tremors could not only demolish settlements, but also affect global climate patterns. The potential for liquid water is another double-edged sword. While it is a vital element for life, large bodies of water can also lead to violent weather patterns, including storms and flooding. If Luyten B possesses water in significant quantities, it could introduce another layer of danger that must be addressed for a sustainable human presence. All these factors combine to paint a complex and challenging picture for the prospect of human life on Luyten B. Intense atmospheric pressures present remarkable challenges for human technology and equipment, particularly when exploring environments such as the deep oceans or distant planets. For instance, as one descends into the ocean, the pressure increases significantly with every layer of water above. At depths where the pressure is many times greater than what we experience at sea level, even the most robust submarines must be designed with specialized materials and structures capable of withstanding these extreme forces. High pressures can lead to structural failure in equipment that is not adequately designed for such conditions. The materials used in construction must exhibit not only strength, but also flexibility to prevent catastrophic collapse. This is particularly evident in vessels intended for deep-sea exploration, where engineers incorporate thicker hulls, reinforced joints, and specialized pressure-resistant materials. Such advancements ensure that technology can operate effectively and safely under these conditions. When we consider planetary exploration, like missions to the gas giants or their moons, the sheer atmospheric pressure can pose similar risks. For example, missions to investigate Jupiter's moons, which might host subsurface oceans under ice, would require landers and probes that can endure not just the pressure, but also the chilling temperatures and corrosive environments. This means that scientists and engineers must innovate continuously, creating instruments that can provide valuable data without being compromised by the pressing forces of the atmosphere or ocean. Designing technology for these extreme environments forces us to push the boundaries of engineering and materials science. It challenges researchers to think creatively and develop solutions that allow humans to explore and understand environments once thought inaccessible, opening up possibilities for deeper knowledge of our world and beyond. The discovery of a planet's atmospheric composition can evoke significant concerns about the health risks for astronauts who may one day explore its surface. When scientists analyze the atmosphere of distant planets, they look for the presence of harmful gases, high radiation levels, or extreme weather patterns. If a planet's atmosphere contains toxic or corrosive elements, it poses a serious threat to human life. For instance, if a planet has high concentrations of gases like carbon dioxide, methane, or ammonia, these can lead to serious health issues for astronauts, such as respiratory problems or poisoning. In addition to toxic gases, an atmosphere lacking oxygen is equally perilous, as it could render astronauts incapable of survival without proper life support systems. The challenge becomes not just about navigating the surface, but also ensuring that astronauts have the necessary technology to protect them from the planet's inhospitable conditions. Moreover, if scientists uncover strong radiation fields or an atmosphere thin enough to expose astronauts to cosmic rays and solar flares, it could significantly increase their risk of developing illnesses such as cancer or acute radiation syndrome. This potential for harm calls for extreme caution in selecting targets for human exploration. It emphasizes the importance of rigorous evaluation of atmospheric data before any mission can be launched. Understanding a planet's atmospheric composition doesn't merely serve to ignite curiosity, it fundamentally shapes the feasibility of space missions. Space agencies must develop advanced technologies and strategies to keep astronauts safe from harmful environmental elements and ensure they can carry out their explorative tasks without jeopardizing their well-being. This complex interplay between curiosity and caution illustrates the delicate balance required in the pursuit of interplanetary exploration. The exoplanet HD 209458b, often referred to as Osiris, presents an intriguing yet intimidating prospect for future missions due to its extreme weather phenomena. This gas giant is situated about 60 light-years away in the constellation Pegasus. Known for its scorching temperature and dynamic atmospheric conditions, these factors raise significant challenges for any potential exploratory endeavors. With surface temperatures exceeding 1,000 degrees Celsius, Osiris experiences intense heat that contributes to a tempestuous atmosphere. This planet is notorious for scorching winds reaching speeds of over 8,000 kilometers per hour. Such ferocious gusts dramatically reshape any clouds formed in its atmosphere, creating an ever-shifting landscape filled with violent storms. These conditions present unique obstacles for spacecraft that aim to study its atmosphere. The potential for high-velocity wind currents introduces risks that could hinder flight maneuvers, data collection, and overall mission integrity. Moreover, the chemical composition of Osiris's atmosphere further complicates matters. The presence of various elements, including water vapor and carbon monoxide, creates a potent environment of extreme weather patterns. Atmospheric models suggest that the combination of intense heat and rapid winds could generate massive clouds of metallic compounds, forming storms that might be unlike anything observed in our own solar system. Understanding how these elements interact forms a substantial part of the scientific inquiry, but also presents risks for probe designs and instrumentation. Mission planners must take these risks into consideration when designing instruments and selecting landing sites. High levels of radiation and extreme temperatures must be endured by any equipment sent to study this broiling world. The harsh conditions on HD 209458b will not only shape the type of technologies developed for exploration, but also dictate the very approach scientists take in understanding this captivating exoplanet. HAT P11b is an intriguing exoplanet, notable for its low gravity, which is just a fraction of what we experience on Earth. This reduced gravitational force could have significant implications for human adaptability during exploration. When humans encounter environments with lower gravity, like that on HAT P11b, our bodies would respond in fascinating ways. Low gravity affects our muscles and bones, leading to potential atrophy and weakening over time. In environments where the gravitational pull is diminished, astronauts might find it easier to move about and perform certain tasks, requiring less energy for lifting movements. However, the long-term effects could be problematic. Without adequate resistance activities, human strength and bone density could decrease, posing challenges when attempting to return to Earth or adjust to different gravitational environments upon physical re-entry. Additionally, lower gravity might impact various physiological processes, including fluid distribution throughout the body. Astronauts could experience shifts in vision, blood circulation, and overall bodily function. These adaptations require careful study and preparation to ensure that explorers maintain optimal health and performance. Understanding these effects would be vital in designing habitats, exercise regimens, and technologies for safe exploration on HAT P11b or similar celestial bodies. Future human missions to exoplanets like HAT P11b will undoubtedly need to consider these unique challenges. Researchers will be keen to develop countermeasures that could sustain human health and adaptability, allowing explorers to thrive in environments that are vastly different from what we know on Earth. Preparing for both the excitement and the unique demands of low-gravity exploration will be essential in our quest to understand the universe. Astronauts are often surrounded by a stunning tapestry of colors and visual phenomena when they venture into space or land on other planets. These vibrant hues can stem from various elements in the environment, such as atmospheric conditions, mineral compositions, or even the unique interplay of light in an alien atmosphere. In particular, planets like Mars and Venus showcase distinctive reds, oranges, and deep blues, which may be awe-inspiring yet also create a striking sense of disorientation for those trying to navigate within these landscapes. The disorientation arises partly because our brains are wired to interpret familiar colors and scenery based on earthly experiences. When faced with colors and visual effects that are entirely alien, such as the swirling clouds of gas on Jupiter or the striking red skies of Mars, one's sense of direction can be skewed. This disconnection from relatable references can make it difficult for astronauts to gauge distances or orientations. The unusual lighting conditions, where shadows are cast in unfamiliar ways or colors blend in unexpected patterns, can further confuse their spatial awareness. Moreover, some planetary environments may exhibit optical illusions that challenge the astronaut's perception of size and scale. For instance, atmospheric refraction may cause distant objects to appear closer or change how objects are perceived in terms of distance and depth. This optical trickery complicates the already demanding task of piloting spacecraft or navigating on foot, necessitating additional focus on reliable instruments and signals rather than solely relying on their own visual cues. As astronauts push the boundaries of exploration, understanding and training for the potential disorientation caused by these vibrant colors and strange visual effects will be essential. By preparing them for these unexpected sensory experiences, space agencies can help ensure that humans can not only explore these new worlds with wonder, but also navigate them safely and effectively. PDS-70b is a fascinating exoplanet located approximately 130 light-years away from Earth, nestled within the constellation Centaurus. It is notable not only for its size, being about 6 times the mass of Jupiter, but also for its unique set of characteristics that ignites curiosity among scientists and caution in understanding its potential danger. This planetary body exists in a protoplanetary disk, which is a disk of gas and dust surrounding a young star. The environment surrounding PDS-70b is a breeding ground for intense conditions and phenomena. One of the most striking features of PDS-70b is its atmosphere. Composed of hydrogen and helium, it also exhibits signs of carbon monoxide and other complex molecules. These gases can lead to extreme weather patterns, with fierce storms likely swirling across its surface. The planet has an unusual brightness that suggests it is still forming, possibly drawing in material from its surroundings. This ongoing accumulation can result in turbulent processes which could potentially expel debris and harmful materials into space, posing a risk to nearby celestial bodies. Another aspect that raises eyebrows among researchers is the temperature. PDS-70b is believed to have scorching temperatures that far exceed those found on Earth. The intense heat not only affects the atmospheric conditions, but also raises questions about the behavior of materials on the planet's surface. How environment reacts to such an extreme climate can result in exotic phenomena that we can hardly imagine, posing an unknown threat should any of these processes affect surrounding planets or regions of space. Furthermore, PDS-70b showcases the potential to interact destructively with its environment. As a gas giant in a young star system with ongoing formation processes, its immense gravitational force could influence smaller bodies, altering their orbits and possibly causing collisions. Such interactions and the chaotic nature of its environment make PDS-70b a compelling and somewhat alarming subject of study, as scientists seek to comprehend the broader implications of exoplanet evolution and their impacts on their galactic neighbors. A planet existing within a dual star system presents a unique array of environmental challenges that would greatly affect any human visitor. Unlike the familiar solar system with a single sun, the gravitational forces and varying light conditions created by two stars can lead to unpredictable weather patterns. These patterns can result in extreme temperature fluctuations, as the interplay between the stars could cause periods of intense heat followed by sudden chill, potentially affecting everything from basic survival to the functioning of equipment. The complexity of day and night cycles is another significant factor. With two stars, the length and intensity of daylight can vary drastically. This inconsistency can disrupt the natural circadian rhythms of humans, leading to disorientation and fatigue. Some areas may experience prolonged periods of illumination, while others may fall into darkness unexpectedly. Such extreme variations could make it exceedingly difficult to establish a routine or predict when to engage in essential activities such as sleep or work. Moreover, the gravitational interactions between the two stars could instigate unpredictable phenomena. The presence of tidal forces might generate elevated seismic activity on the planet's surface. Such geological instability could result in earthquakes or volcanic eruptions that would pose tremendous risks to human explorers. Additionally, the combination of increased radiation exposure due to varying distance from the stars could lead to serious health concerns, including higher risks of cancer or radiation sickness. Finally, the ambient environment may host unusual atmospheric conditions created by the dual star arrangement. This includes erratic winds or sudden storms that could emerge without warning. Such environmental hazards would demand a high level of preparedness, making the survival of human visitors to a dual star system a complex and hazardous endeavor. The interplay of these various factors illustrates the intricacies and challenges faced in such an alien context. The planet TOI 849b, an intriguing discovery in the exoplanet catalogue, presents a unique set of challenges for any prospective explorers. At the heart of this planet lies a core that is believed to be primarily composed of heavy metals and elements, possibly including iron and nickel. This dense core composition could lead to a variety of hazardous conditions that would pose significant risks to exploration teams. One major concern is the extreme gravitational forces exerted by such a massive core. TOI 849b is classified as a super-Earth, meaning it is larger than our own planet, and this size, combined with the high density of its core, could create gravity levels that are decidedly higher than those experienced on Earth. For explorers, this could result in physical strain and health complications, making it difficult to move and operate effectively in the environment. Furthermore, the geological instability that might arise from a core rich in heavy metals could lead to intense volcanic activity or seismic events. Explorers could face not only an inhospitable atmosphere, but also potentially deadly eruptions or quakes that would jeopardize their safety. This volatile environment would demand sophisticated technology and robust protective measures, adding another layer of complexity to any mission. Additionally, the atmospheric conditions surrounding TOI 849b are likely to be harsh. High-pressure environments, extreme temperatures, and perhaps toxic gases could create an array of obstacles. These factors, combined with the gravitational and geological risks, paint a daunting picture for what an exploratory mission to this super-Earth could entail. As we uncover more about this fascinating planet, the challenges it presents only deepen our sense of wonder about the mysteries lurking in our universe. Rapid changes in temperature on Earth can significantly impact human missions, especially those related to space exploration or scientific research. Such temperature fluctuations can disrupt technology, undermining equipment that is crucial for the success of any mission. Sensitive instruments designed to collect data or support human life have specific operational thresholds. When temperatures change unexpectedly, these devices may malfunction, leading to compromised mission objectives or, in extreme cases, a complete failure. Human physiology is also a vital consideration. Rapid temperature changes can lead to health risks for astronauts and researchers. The human body is adapted to maintain a stable internal environment, but extreme heat or cold can bring about physiological stress, dehydration, and even hypothermia. For instance, if temperatures on a spacecraft or a research base fluctuate dramatically, the crew might face challenges in adjusting their thermal regulation, increasing the likelihood of heat-related illnesses or cold exposure. Furthermore, these temperature shifts can impact logistics and planning for missions. Whether launching from a spaceport or conducting experiments in the field, climate-related changes could delay operations, require additional resources to manage risks, or alter the timing of critical activities. This unpredictability can be costly, not only in terms of financial investment, but also in the potential for lost scientific discoveries or extended timelines for human exploration. Considering these factors, it becomes clear that managing the immediate threats posed by rapid temperature changes is vital for the success of human missions. Careful planning, robust technology, and solid emergency protocols are all essential components in ensuring that humanity can navigate the challenges presented by our ever-changing environment. WASP-33b presents a formidable challenge for any potential life forms due to its extreme temperatures, which can soar well beyond what any known organism can stand. This exoplanet, located about 170 light-years from Earth, is classified as a hot Jupiter, a category of gas giants that orbit very close to their stars. As a result, temperatures can reach an astonishing level, often around 2,700 degrees Celsius. Such relentless heat not only makes the existence of life as we understand it nearly impossible, but also raises fascinating questions about the nature of life itself. These scorching conditions mean that water, a crucial ingredient for life on Earth, would not remain in a liquid state. Instead, it would vaporize instantaneously. Furthermore, the intense heat and the windy atmosphere, laden with turbulent storms, would make any atmospheric stability unlikely. The very elements that contribute to the formation of life as we know it would find themselves in a relentless battle against the elements, rendering survival in any recognizable form improbable. Moreover, WASP-33b's proximity to its star subjects it to extreme tidal forces. This leads to tides that may rival those found in the most active volcanic environments, creating an erratic and unstable environment. With such a volatile atmosphere, any potential biochemistry could be severely disrupted. Life, which often requires stable conditions to evolve and thrive, would find itself facing insurmountable adversity on such a planet. These insights compel us to rethink our understanding of habitability. While Earth shares vital characteristics with some exoplanets, the existence of life might thrive in conditions we once deemed impossible. The extreme environment of WASP-33b challenges us to expand our perspectives on where life might exist, pushing us to explore a broader range of planetary conditions in our search for the unknown. Extreme winds on WASP-33b create sound patterns that are unlike anything found on Earth, yet these alien noises offer a fascinating glimpse into the planet's conditions. WASP-33b is a particularly intriguing exoplanet, located approximately 10,000 light-years away in the constellation Cygnus. It is classified as a hot Jupiter, which means it has a gaseous composition and orbits very close to its star, resulting in blistering temperatures and fierce atmospheric conditions. These extreme winds can give rise to sound waves that are produced by the turbulent motion of the atmosphere. The unique interaction between the intense heat from the nearby star and the planet's thick cloud cover could lead to wind speeds exceeding 600 miles per hour in certain areas. As these winds rush and collide, they generate a cacophony of sound waves that reverberate through the atmosphere and can be interpreted in various ways. Scientists use data from spectroscopic analyses to simulate what these sounds might resemble, creating an auditory landscape that seems eerily alive. When we think about the origins of terror, our minds often draw connections between unsettling noises and fear. The sounds generated by the extreme winds on WASP-33b could evoke a primal sense of dread in those who encounter these simulations. Just as certain frequencies can trigger anxiety or discomfort in humans, the alien sounds of this distant world may produce similar feelings upon hearing them. The combination of the sheer power of these winds and their mysterious nature may amplify our inherent fear of the unknown. This exploration into alien soundscapes takes us not only into the depths of space, but also into our own psychology. As we analyze these extreme phenomena, we may find that even across light years, there are echoes of humanity within the cosmos. The allure of the unknown mingles with our intrinsic reactions, reminding us that the universe holds secrets that can challenge our understanding and even stir our deepest fears. The potential for radiation on GJ 3021b poses significant challenges for the health and safety of any hypothetical explorers venturing to this exoplanet. GJ 3021b lies within a star system where its host star, a red dwarf, emits strong solar flares and intense bursts of ultraviolet and X-ray radiation. Unlike our Sun, which has a well-studied solar cycle, red dwarfs can produce unpredictable and powerful emissions that have the potential to create hazardous conditions for unprotected humans. Explorers on GJ 3021b would face exposure to both cosmic radiation and radiation from the star itself, which could lead to acute health effects. Prolonged exposure to high levels of radiation can increase the risk of cancer, damage to the nervous system, and various other health complications. Particularly concerning is the potential for radiation sickness, which can manifest with symptoms such as nausea, fatigue, and severe skin burns in extreme cases. This would necessitate substantial protective measures to ensure the explorers' well-being during their stay. To mitigate these dangers, any exploration mission would need to incorporate advanced shielding technologies. These could include specially designed spacecraft equipped with materials that block harmful radiation more effectively, as well as habitats on the planet's surface that are buried beneath layers of soil or situated in naturally shielded locations, such as caves. Life support systems would also require robust monitoring and even potentially the use of pharmaceuticals to manage acute exposure effects. As scientific understanding of radiation levels and their potential impact continues to evolve, it is imperative for future missions to develop comprehensive health protocols. This would not only involve monitoring exposure levels, but also devising strategies for emergency evacuation in the event of acute radiation exposure. The exploration of GJ 3021b holds immense potential for discovery, yet the unpredictability of its radiation environment serves as a sober reminder of the risks involved in venturing beyond our home planet. On the distant exoplanet GJ 3021b, scientists speculate the presence of eerie geological formations that could both captivate and haunt any human visitors. This planet, located roughly 50 light-years from Earth, sits in a binary star system, providing a unique array of environmental conditions. The extreme atmospheric pressure and temperatures could give rise to strange and striking structures, possibly resembling jagged peaks or sprawling canyons, carved by relentless winds and chemical processes unlike anything found on our home planet. One particularly haunting possibility involves the formation of alien crystals, growing in bizarre shapes that reflect the unusual chemical composition of GJ 3021b's atmosphere. These crystals could shimmer under the light of the twin stars, creating a visual phenomenon that might be both beautiful and unsettling. Their sharp, angular forms could hint at a world where life has evolved in drastically different ways, leaving human visitors with a sense of unease as they navigate these unfamiliar landscapes. Additionally, large volcanic features may dot the surface, products of the planet's geological activity. These volcanoes could potentially spew unusual gases or molten substances, creating an otherworldly haze that veils the landscape in mystery. The sound of distant eruptions might echo across the plains, adding an auditory layer to the eerie atmosphere, where each rumble resonates with the possibility of something unseen lurking beneath the surface. As explorers set foot on GJ 3021b, they may find themselves surrounded by a panorama that is entirely foreign yet strikingly beautiful. The daunting geological formations could serve as a constant reminder of the planet's alien nature, evoking thoughts of the challenges that come with understanding a world that thrives under conditions we can hardly imagine. Such a place would undoubtedly ignite curiosity and caution in equal measure, leaving visitors both intrigued and haunted by the mysteries of an alien landscape. The exoplanet known as 55 Cancri d is located approximately 40 light-years away from Earth and is renowned for its extreme conditions, which pose considerable dangers for any potential astronauts. This planet is classified as a super-Earth and is believed to have a rocky surface. However, it is its stormy atmosphere that truly sets it apart. Astronomers have detected fierce weather phenomena that can reach violently high speeds, with storms that might rival those seen in the most tumultuous parts of our own planet. These unpredictable storms are not just terrifying in terms of power, they also bring a host of challenges for human explorers. The atmospheric pressure on 55 Cancri d is estimated to be far greater than that on Earth. This means that astronauts would be subjected to overwhelming forces during a storm. The violent winds alone, swirling at astonishing velocities, could wreak havoc on any spacecraft or habitat designed for human comfort and safety. Structural integrity becomes a critical concern as these winds threaten to dismantle equipment and habitats. Temperature fluctuations could also inflict harm during these storms. Given that 55 Cancri d orbits very close to its parent star, temperatures can be extreme. When combined with the storm systems, the rapid shifts in temperature could challenge even the most advanced life support systems. This environment may be hostile in ways that current technology cannot fully mitigate, presenting dangers from thermal shock and potential equipment failure. Furthermore, scientists have theorized that some storms may be accompanied by electrical phenomena, such as lightning strikes, creating an additional risk for those attempting to explore this extraordinary world. The intensity and unpredictability of such events could make planning successful missions exceedingly difficult, highlighting the intricate balance of exploring beyond our solar system while facing nature's most extreme elements. The extreme gravitational forces of different planets present a significant challenge for human exploration and the equipment needed for such missions. Each planet within our solar system demonstrates unique gravitational characteristics, influencing how spacecraft are designed and how astronauts interact with their environment. For instance, the gravity on Mars is about 38% that of Earth, which means humans would weigh substantially less. This lighter weight can aid maneuverability during exploration, but also demands a rethinking of how we approach physical exertion and tasks in that reduced gravity. When it comes to equipment, the gravitational pull dictates not only the weight that astronauts can safely carry, but also the design of vehicles and tools. Transporting scientific instruments necessitates careful consideration so they can operate effectively under a different gravitational environment. For example, rovers designed for Mars must be lighter and more agile than those intended for Earth, ensuring they can traverse the rocky terrain without becoming overwhelmed by their own mass. Loading and transporting supplies also require innovative solutions, as traditional Earth-centric calculations can lead to inefficiencies. On gas giants like Jupiter, the situation is even more complex. The immense gravitational pull poses additional hazards, such as extreme atmospheric pressure and a lack of solid surface. Here, human exploration becomes a theoretical discussion rather than a practical reality, as any equipment designed for such conditions would need to withstand crushing forces while providing life support to astronauts. The very concepts of lander and habitat design must be completely reimagined, focusing instead on potential aerial or floating stations. Understanding these gravitational influences helps scientists and engineers plan missions that are not only feasible, but also safe for human explorers. As we advance our knowledge of the cosmos, grappling with these challenges shapes our future in space exploration, pushing the boundaries of what is possible. The quest to explore our solar system is inherently tied to the forces that govern the planets, making it an adventure into the very fabric of our universe. Proxima Centauri C, an intriguing exoplanet orbiting the closest star to our solar system, presents significant challenges for human exploration, primarily due to its atmospheric conditions. Scientists believe that Proxima Centauri C is a super-Earth, which means it is larger than Earth, but lacks the necessary characteristics that might support human life. The atmosphere on this planet, if it exists, is likely to be hostile. Research suggests that Proxima Centauri C might be exposed to intense stellar radiation from its parent star, Proxima Centauri. Being a red dwarf, Proxima Centauri frequently emits powerful flares that can strip away atmospheres and bombard planets with harsh radiation. This radiation poses a severe risk to human explorers, as prolonged exposure could result in detrimental health effects, including increased cancer risk and other radiation-related illnesses. There is also speculation about the composition of the atmosphere. It may contain toxic gases or lack essential elements like oxygen, creating a formidable barrier to human colonization. Furthermore, the planet's gravity, coupled with its potential atmospheric pressure, may not be conducive to human survival. This raises questions about the safety of human habitation or even short-term exploration missions, as the environment could be extremely unforgiving. Understanding Proxima Centauri C's atmosphere is crucial for any future exploration efforts. Without the development of advanced life support systems capable of mitigating these environmental hazards, the prospect of sending humans to this nearby world remains a distant dream. This exploration would not only test our technological capabilities, but also broaden our understanding of habitability in the universe. Proxima Centauri C, an exoplanet orbiting the closest star to our solar system, brings with it a host of challenges that would complicate human exploration. The unpredictable weather patterns on this distant world could pose significant hazards for astronauts, making any mission fraught with potential complications. Given its position within the habitable zone, expectations might suggest a more temperate climate. However, the reality could be far from that, with extreme conditions that remain largely unknown. One of the complexities of this world arises from its potential variability in temperature and atmospheric composition. Should scientists discover that Proxima Centauri C experiences violent storms, intense winds, or even erratic precipitation, these factors would influence not only the safety of landing and taking off, but also daily activities of astronauts on the surface. Unpredictable weather could hinder travel between habitats, impact the collection of vital resources, and even disrupt scientific experiments. Additionally, if fluctuations in atmospheric pressure or temperature were frequent, the life support systems aboard the spacecraft and habitats would need to adapt in real time. As astronauts conduct their work in such an environment, ensuring their health and safety would become a paramount concern. Reliance on technology would be crucial, yet if equipment were to fail amid harsh weather, the consequences could be dire, placing astronauts in precarious situations. To tackle these formidable challenges, thorough preparation is paramount. Astronauts would require advanced training, sophisticated weather prediction models, and highly resilient equipment to withstand the extreme conditions Proxima Centauri C might throw their way. The prospect of venturing to this intriguing planet is enticing, yet the complexities posed by its weather demand careful consideration and innovative solutions. The planet Exo 1b presents one of the most extreme atmospheres found outside of our own solar system. Located approximately 51 light-years from Earth, this exoplanet orbits a star similar to our own Sun and features a thick atmosphere composed primarily of hydrogen and helium. Temperatures on its surface soar to levels that would be unbearable for human life, often exceeding 1,000 degrees Fahrenheit. This relentless heat, combined with high pressures, creates an environment that is both hostile and stifling. For explorers who might one day venture towards Exo 1b, the oppressive conditions could provoke a profound sense of claustrophobia. Encased within heavy, specialized suits designed to withstand its intense atmosphere, each explorer would feel the press of thick, heavy air around them. Such technological barriers meant to protect would instead act like a cage, restricting movement and enhancing the feeling of confinement. Every breath they take would be filtered and controlled, further amplifying the sensation of being trapped in a foreign world. The constant pressure from the surrounding gases would serve as a continuous reminder of their vulnerability in such a dangerous environment. With exceedingly limited visibility and a landscape that is alien to human experience, the explorers would be surrounded by an oppressive atmosphere that mirrors the psychological feeling of being cornered. The sensation of being unable to escape would permeate their thoughts, creating an overwhelming awareness of their isolation from familiar, breathable environments. In addition to the physical restrictions, the environmental conditions would continuously bombard the explorers with pressure and heat, overwhelming their senses. The combination of life support systems, ambient noise from survival equipment, and the sense of weightlessness or heaviness would transform their surroundings into an unsettling experience. The oppressive atmosphere of Exo 1b would serve not just as a barrier to exploration, but also as a mental challenge, shaping perceptions of space, survival, and solitude at the edge of humanity's reach. As scientists explore the potential for human missions to planets beyond our solar system, such as Exo 1b, the signs of extreme weather on these distant worlds can raise significant concerns. Exo 1b, located in a solar system not so far from our own, is characterized by conditions that could pose serious risks to any exploratory endeavor. The planet orbits its star in a way that places it within the grasp of intense, radiant heat. This could lead to lethal temperatures that far exceed what human technology can currently withstand. Moreover, the atmosphere of Exo 1b is believed to be thick and laden with corrosive gases. Extreme weather phenomena such as violent storms and frequent lightning could potentially erupt from this dense atmosphere. Such conditions can not only hinder visibility, but also lead to unpredictable and dangerous flight paths for atmospheric vehicles. Any human mission aiming to explore or establish a presence on Exo 1b would need to account for these tempestuous conditions, as they could delay launches, impact safety, and significantly complicate landing procedures. Adding complexity to the already challenging environment, the gravity on Exo 1b is expected to be vastly different from Earth's. This factor, coupled with the high-pressure atmosphere, can lead to altered weather dynamics, resulting in heavier rains and turbulent winds. Such extreme meteorological conditions would not only complicate initial landings, but also pose ongoing risks to life support systems and integrity of habitats designed for human survival. Understanding these potential hazards underscores the need for extensive research and technological advancements before considering a human mission to Exo 1b. As we progress in our exploration of the cosmos, grasping the severe impacts of extreme weather on distant worlds will be essential in ensuring the safety and success of future interstellar journeys. K2141b is a fascinating exoplanet located approximately 130 light-years from Earth, noted for its extreme conditions. The planet is tidally locked, meaning one side constantly faces its star, while the other remains in perpetual darkness. This unique rotation causes intense tidal forces that can drastically affect the planet's surface and atmosphere, creating significant obstacles for any potential exploration. The extreme gravitational pull from the nearby star has led to the formation of extraordinarily high temperatures on the day side, reaching up to 2,500 degrees Celsius. This searing heat can vaporize metals and create a molten landscape, making it nearly impossible for conventional spacecraft or rovers to survive. Exploration missions would require cutting-edge technologies and materials capable of withstanding not just the heat, but also the corrosive environments that may be present due to interactions with the atmosphere. On the night side of K2-141b, conditions are equally hostile but vastly different. The lack of sunlight could lead to even colder temperatures, potentially freezing any volatile compounds or causing drastic atmospheric changes due to the severe temperature disparity. This means that any exploratory equipment would need to be equipped to deal with rapid and extreme temperature changes, which adds another layer of complexity to mission planning. Besides the environmental extremes, the tidal forces also influence the geological activities on K2-141b. Volcanic eruptions are likely more frequent due to the constant strain inflicted by gravitational forces. These eruptions can release ash and gases into the atmosphere, posing further challenges for exploration and making the landscape highly unstable. Consequently, the combination of these extreme conditions, the scorching heat, freezing cold, and active geology, makes K2-141b a scientifically intriguing target that demands innovative approaches in future exploration endeavors. K2-141b presents a mesmerizing yet daunting landscape that captures the attention of astronomers and scientists alike. This exoplanet, located approximately 250 light-years away from Earth, boasts a surface covered in molten lava. Its extreme conditions arise from the intense heat generated by a close orbit around its host star, resulting in temperatures soaring to around 2,500 degrees Celsius. The planet's terrifying features include vast oceans of molten rock, which create a constantly shifting terrain. These lava seas can be likened to a nightmarish version of Earth's volcanic landscapes, but magnified on a colossal scale. The sight of glowing liquid rock stretching as far as the eye can see presents challenges for researchers in understanding planetary formation and composition. It raises questions about how such an extreme environment influences the possibilities of life, or if life could ever exist under these lethal conditions. Additionally, K2-141b experiences a staggering phenomenon known as tidal locking, meaning one side of the planet is perpetually facing its star. This results in a striking contrast between a searing hot daytime environment and a much cooler but still hostile nighttime zone. The complexity of these contrasting ecosystems poses significant challenges, as explorers of this alien landscape must theorize about the atmospheric dynamics and chemical reactions that could occur given such extreme temperatures and conditions. The horrifying nature of K2-141b serves as a vivid reminder of the diversity of planetary environments beyond our solar system. Each new discovery pushes the boundaries of our understanding of what is possible and what makes a planet potentially habitable. Observing and studying such intimidating worlds can help unravel the mysteries of planetary systems and their evolution throughout the cosmos. The planet's partially molten surface presents a unique challenge for human exploration that raises legitimate concerns about both safety and mission viability. Many scientists believe that such a surface could destabilize quickly, resulting in unpredictable geological activity, such as eruptions or shifts in landscape. This potential for sudden changes poses inherent risks to astronauts who venture onto the planet. To further complicate matters, the temperature fluctuations on these partially molten surfaces can be extreme. This means that any exploration equipment or human habitats must withstand not only high temperatures, but also the effects of molten material spilling over or pooling in areas where explorers may be working. The engineering designs for such components become significantly more complex, requiring advanced materials and technologies to withstand conditions that could easily damage or destroy less robust structures. Additionally, the partially molten terrain complicates navigation and landing strategies. Traditional methods of landing and moving across solid ground become more challenging when faced with treacherous flows of molten rock or shifting landscapes. This creates a greater need for real-time monitoring and adaptability, adding layers of complexity to mission planning and execution. Each step of the exploration process demands thorough consideration of these factors. The fears surrounding human exploration are not merely about the immediate dangers, but also about the long-term sustainability of missions on such dynamic surfaces. Will humans be able to establish functioning habitats? Can we devise systems that ensure safety without sacrificing scientific goals? These critical questions reflect the hurdles we must overcome if we wish to unlock the secrets that lie beneath the haze of a planet with a partially molten surface. K2-141b, a planet located approximately 240 light-years away from Earth, presents a number of extreme atmospheric conditions that would likely induce psychological stress for any hypothetical visitors. First and foremost, the planet is classified as a lava world, meaning its surface is molten due to intense temperatures that can reach as high as 3,000 degrees Fahrenheit. Such extreme heat not only poses a threat to physical well-being, but could also create a constant sense of impending danger for explorers, leading to heightened anxiety and vigilance. The atmosphere of K2-141b primarily consists of a thick layer of gas that includes sodium and potassium. This composition leads to significant chemical reactions that produce flash evaporation and potentially toxic conditions. Visitors would find themselves in an environment that is not only inhospitable but laden with harmful gases. The psychological burden of navigating through a landscape that could cause severe harm would be overwhelming, fostering feelings of helplessness and fear. Moreover, K2-141b experiences extreme atmospheric pressure that far exceeds what humans are accustomed to. This level of pressure would not only have physical repercussions, but also contribute to mental strain as individuals confront sensations of confinement or suffocation. The oppressive environment could trigger claustrophobia or a heightened sense of isolation, forcing visitors to grapple with the reality that they are far from the safety of home. Finally, the relentless nature of environmental conditions on K2-141b would likely exacerbate feelings of stress. Regular volcanic eruptions and lava flows create a dynamic landscape that can change rapidly and unpredictably. For anyone attempting to explore this alien world, the constant threat of sudden geological activity would mean that their mental state must remain one of perpetual alertness. This unrelenting need for vigilance could lead to fatigue and burnout, making the experience not just physically dangerous, but mentally grueling as well. LHS 582b presents a unique and harsh environment for potential human exploration. Unlike Earth, this exoplanet has no protective atmosphere. This absence means that travelers would be directly exposed to the unforgiving elements of space. Cosmic radiation, which is normally absorbed by an atmosphere, would bombard any unprotected human visitors, significantly increasing the risk of cancer and other health complications. Moreover, the lack of atmospheric pressure would lead to other life-threatening conditions. On Earth, our atmosphere maintains a balance necessary for human survival. Without it, liquids like water would boil at lower temperatures, making it impossible to retain liquid water on the planet's surface unless contained within pressurized vessels. This would add a layer of complexity to colonization efforts, as travelers would need sophisticated technology to sustain basic life functions. Additionally, the absence of an atmosphere means that LHS 582b could experience extreme temperature fluctuations. Without the insulating effects of air, temperatures could soar during the day while plunging at night. This variability poses significant challenges for any human settlements. Specially designed habitats would be necessary to shield inhabitants from thermal extremes, providing not only temperature control, but also protection from the relentless solar winds. The rugged landscape, combined with these environmental hazards, underscores the daunting challenges that await humans on LHS 582b. Any mission aimed at exploring this distant world would require careful planning, advanced technology, and a thorough understanding of how to safeguard against the planet's hostile conditions. The possibility of encountering toxic substances on the surface of a celestial body instills significant concern among potential explorers. Imagine stepping onto a new world, only to discover that the soil or rocks contain harmful elements. This scenario transforms the fantasy of exploration into a perilous reality. The risks associated with exposure to toxins pose immense challenges for both human safety and mission success. Such hazards could stem from naturally occurring compounds or remnants of past activities, such as mining or chemical processes. Explorers might face various types of toxicity. Some substances could cause immediate health effects, while others might have long-term implications, like contamination of life support systems or equipment. The fear extends beyond the immediate well-being of the astronauts. It raises questions about potential contamination of the environment, which could impede future exploration efforts for generations. The last thing scientists want is to introduce Earth-based microorganisms into an ecosystem that may exist or may be pristine. Furthermore, the presence of toxic materials complicates the logistics of space missions. Engineering safe habitats and protective suits requires advanced technology and thorough planning. Explorers must be equipped with the necessary tools to analyze the surface, identify hazardous substances, and determine their potential impacts. This necessity not only raises costs, but also increases the complexity of missions, leading to fears surrounding the feasibility and safety of future explorations. The discovery of toxic substances on a celestial body could alter our understanding of that world and its history. If explorers learn that these toxic elements were once part of a vibrant environment, it opens fascinating discussions about what conditions may have existed. However, the reality of navigating this treacherous landscape demands respect and caution, forcing future missions to tread carefully in their quest for knowledge. GJ 1132b, an exoplanet located about 41 light-years away in the constellation Vela, presents a captivating yet alarming scenario when we consider its potential for volcanic activity. This rocky planet orbits its star closely, leading to extreme temperatures and intense geological processes. With its surface possibly being reshaped by frequent eruptions, the planet becomes a startling reminder of the chaotic and fiery forces that can dominate a world. The prospect of active volcanoes on GJ 1132b raises significant concerns for any hypothetical human exploration. If humans were to visit, they would face an environment marked by relentless lava flows, ash clouds, and possibly toxic gases released during eruptions. These volcanic events could not only damage spacecraft, but also pose serious risks to human health and safety. The terrifying unpredictability of such eruptions could turn a planned mission into a desperate scramble for survival. Exploring geological features reshaped by volcanoes requires advanced technology and adaptive strategies. The harsh environment, characterized by barren landscapes and extreme temperatures, plays a crucial role in understanding planetary evolution and the potential for habitable conditions. Yet, GJ 1132b's volcanic activity could easily derail any efforts to study its geology, making it seem more like a scene from a disaster film than a scientific expedition. As scientists study such planets, their findings often evoke questions about the balance between geothermal activity and habitability. Could a world rife with explosive volcanic activity still support life? For GJ 1132b, its fiery landscape serves as a possible clue to the evolutionary tales written in the stars, while simultaneously guiding our imaginations to ponder the limits of what humanity could endure in its quest for knowledge. The unusual rotation of a planet can significantly influence the experiences of human visitors, shaping everything from the length of day and night to the apparent motion of the stars. For instance, if a planet has a very slow rotation, a single day could stretch into weeks or even months. Human visitors might find themselves living in a world where the sun barely rises and sets, leading to extended periods of light followed by long, dark nights. This prolonged exposure to either light or darkness could have profound effects on human circadian rhythms, altering sleep patterns and overall health. Conversely, planets with rapid rotation could experience the opposite effects. A swift rotation might lead to days that are incredibly short. Imagine rushing through an entire workday in mere hours, with the sun racing across the sky. Such a scenario could challenge not only the physical routines of visitors, but also their psychological well-being, as the fast-paced environment could create a sense of perpetual urgency and disorientation. Additionally, the planet's axial tilt could further impact visitors' experiences. A significant tilt might result in extreme seasonal changes, making the climate vary dramatically within short periods. Human visitors would need to adapt to rapidly shifting temperatures and weather patterns, which could influence not only daily activities, but also the types of habitats and technology required for survival. Finally, the gravitational effects tied to a planet's rotation could not be overlooked. If the planet spins rapidly, it may experience reduced gravity at the equator, impacting basic human functions such as movement and strength. The physical adaptation to a lighter gravitational field would likely present both challenges and opportunities for exploration, making the experience of visiting such a world both fascinating and complex. The exoplanet known as HD 209458c, located approximately 53 light-years away from Earth, presents an environment that elicits significant concern for potential human exploration. With its close proximity to a parent star, temperatures soar high enough to cause a perpetual state of gaseous activity, meaning that the atmosphere is in a turbulent, unceasing state. This planet has earned the nickname Osiris due to its harsh attributes, including high levels of radiation and extreme winds that could pose dire threats to astronauts. Radiation levels on HD 209458c are intensely elevated, primarily because of the proximity to its bright star. This relentless radiation can lead to severe consequences for human health. Astronauts exposed to such an environment could suffer from an increased risk of cancers and other radiation-induced illnesses. The long-term effects may not be immediately visible, but the potential for damage at the cellular level raises alarms about the viability of prolonged exploration missions. Adding to these fears are the extreme winds that can sweep across the planet's surface. The velocities of these winds can exceed hundreds of miles per hour, making any outdoor exposure not only hazardous but life-threatening. The relentless gales could hurl debris at lethal speeds, endangering not just astronauts outside their habitats, but also the integrity of their spacecraft. Engineers would need to design equipment capable of withstanding these fierce conditions, and that further increases the stress associated with missions to such an inhospitable world. These challenges provoke serious contemplation regarding technological advancements and safety protocols. The psychological toll on astronauts preparing for such missions cannot be overlooked. Concerns over radiation, harsh atmospheric conditions, and the required engineering complexities could lead to an overwhelming sense of dread or apprehension. As humanity pushes the boundaries of space exploration further than ever before, understanding the risks associated with worlds like HD 209458c is crucial for the well-being and success of future expeditions. Extreme temperatures on planets pose significant challenges for any potential human missions. Take, for example, the surface of Venus, where the average temperature reaches around 450 degrees Celsius. This scorching heat is far beyond what human bodies can tolerate. It presents obstacles not only for human survival, but also for the durability of spacecraft and technology. Electronic systems and life support systems, crucial for such missions, may fail under such intense conditions. Similarly, the freezing temperatures found on Mars can also create daunting barriers. With average temperatures hovering around -68 degrees Celsius, even the most advanced equipment can struggle to function correctly. Human habitats would need extraordinary insulation and heating systems to ensure comfort and functionality. Developing these complex technologies requires innovative engineering and thorough planning to mitigate risks. Then there is the psychological aspect to consider. Extreme temperatures create isolation and discomfort, which can impact the mental well-being of astronauts. Prolonged exposure to harsh conditions could lead to stress and fatigue, challenging the mission's success. Ensuring that crew members remain motivated and healthy while facing such inhospitable environments is essential for mission planners. Ultimately, preparing for these extremes demands comprehensive research and planning. Scientists and engineers must innovate and test new materials, structures, and life support systems. The quest to brave these temperatures reflects humanity's relentless spirit of exploration, even amid seemingly insurmountable challenges. Each step taken to overcome these environmental obstacles brings us closer to unlocking the mysteries of our cosmic neighborhood. WASP 104b is an exoplanet that has attracted attention due to its extreme atmospheric conditions. It orbits a star located approximately 500 light-years away in the constellation Leo. What makes WASP 104b particularly intriguing is its classification as a hot Jupiter. This means it is a gas giant that is similar in characteristics to Jupiter, but orbits very close to its parent star. The result is an atmosphere characterized by soaring temperatures often exceeding 1,000 degrees Celsius. These scorching conditions create a hostile environment for any form of human exploration. The first major danger lies in the planet's blistering temperatures. Such extreme heat would not only extinguish any conventional spacecraft, but would also pose serious risks to human life. Current space technology is far from equipped to handle environments where temperatures are higher than anything experienced in our solar system. The materials used in spacecraft construction would be overwhelmed by the intense thermal energy, effectively rendering any manned mission unviable without groundbreaking advancements in technology. Moreover, WASP 104b is believed to have a thick atmosphere composed of hydrogen, helium, and possibly other compounds, including water vapor. The pressure within this dense atmosphere would surpass the levels found in Earth's deepest oceans, creating further challenges for human explorers. High pressures could lead to structural failures in spacecraft and life support systems, increasing the risks of catastrophic consequences for any crew attempting to land or study the planet. Adding to these dangers are the fierce storms that likely swirl within this turbulent atmosphere. Observations suggest violent winds that could reach thousands of kilometers per hour. These extreme weather patterns would not only make landing exceedingly difficult, but could also pose significant threats during any potential ascent from the planetary surface. The combination of unyielding heat, enormous pressure, and hazardous weather creates a formidable barrier that raises questions about the feasibility of human exploration beyond our solar system. When contemplating human visitors to planets situated close to their host stars, the risks multiply significantly. One of the primary dangers is the intense radiation emitted by the star. Proximity to a star means that a planet is often bombarded by higher levels of ultraviolet radiation and solar flares. For human explorers, this would pose serious health risks, ranging from increased cancer rates to potential acute radiation sickness over extended exposure. Advanced shielding technology would be essential for any spacecraft, and surface habitats would require protective measures to ensure safety against solar activity. Another significant factor is the extreme temperatures that can accompany close proximity to a star. For many of these planets, the side facing the star could become unbearably hot, while the far side might plunge into frigid darkness. This stark temperature gradient can make survival and sustainability incredibly challenging. Advanced life support systems and thermal control technologies would need to be developed, as human biology requires a stable and moderate environment to function effectively. The gravitational pull from a nearby star can also influence atmospheric retention on these planets. If the planetary atmosphere is thin due to the star's gravitational influence, it might struggle to provide adequate protection from cosmic and stellar radiation. Additionally, a thin atmosphere may limit breathable air resources for visitors, making continuous life support systems vital. Overall, the combined effects of radiation hazards, extreme temperatures, and potential atmospheric challenges make the idea of human visitation to planets near their stars a complex endeavor. With each factor adding layers of risk, careful planning and innovative technology would be necessary to ensure that any journey towards these close celestial neighbors is both safe and feasible. Gliese 357b is a fascinating exoplanet that captures the imagination with its extreme conditions. Situated about 41 light-years away from Earth, it presents a unique challenge for future explorers. The most notable environmental threat lies in its significant gravitational pull, which is roughly 2.5 times that of Earth. This means that any human or robotic explorers would experience immense physical strain, making mobility difficult and increasing the risk of injury. Additionally, this planet orbits within its star's habitable zone, suggesting that it could possess surface temperatures suitable for liquid water. However, this warmth does not translate to a hospitable environment. The atmosphere on Gliese 357b is believed to be thick and dense, possibly rich in carbon dioxide and other gases. Such a composition could lead to suffocation risks for any explorers lacking proper life support systems. Another alarming feature is the possibility of volcanic activity on the planet. Some studies suggest that Gliese 357b could be geologically active, which would pose dangers such as eruptions or toxic gas emissions. Not only would this make landing and exploration incredibly hazardous, but the high potential for ash or lava flows could also threaten the safety of exploration equipment. Finally, the presence of intense radiation from its parent star is a critical concern. Without a protective magnetic field like Earth's, the planet exposes explorers to significant cosmic and stellar radiation, increasing the risk of radiation sickness. This environment presents a formidable set of challenges that any future missions would need to address extensively, requiring innovative technology and robust planning to ensure the safety of all involved. The thick clouds enveloping Gliese 357b pose significant challenges for any astronauts who might venture into its atmosphere. As they approach this distant exoplanet, the low visibility caused by these dense clouds could create an unsettling environment. Navigating through a thick mist can lead to disorientation, making it difficult to gauge altitude and direction. Astronauts rely heavily on their surroundings and onboard instruments for situational awareness. The inability to see far ahead could lead to uncertainty regarding their trajectory and an increased risk of colliding with unknown atmospheric phenomena. Furthermore, the atmosphere of Gliese 357b is believed to be rich in gases that could be toxic. The cloud cover, combined with limited visibility, may prevent astronauts from detecting hazardous conditions until it is too late. This uncertainty could heighten anxiety and stress levels among the crew, as they would have to make critical decisions based on incomplete information. Engaging with an unpredictable environment heightens the potential for error, which is a dangerous prospect given the hostile nature of this alien world. To combat these challenges, astronauts would need to rely on advanced technology designed to penetrate the thick cloud layers. Instruments capable of real-time environmental analysis would be essential in guiding their journey and ensuring they can navigate safely. However, even the best technology has limitations, and depending solely on artificial means could lead to a disconnection from their immediate environment, further exacerbating feelings of isolation and unease. The psychological effects of operating in such oppressive conditions cannot be overlooked. The constant feeling of being surrounded by thick clouds could lead to a sense of vulnerability. For astronauts, the beauty of space exploration often lies in the awe-inspiring vistas of the cosmos. But when confined to darkness with minimal visibility, that wonder may be replaced by an overwhelming sense of confinement and uneasiness about the unknown that lies beyond their immediate surroundings. WASP 76b is a gas giant exoplanet that has intrigued scientists with its extreme and often horrifying weather patterns. Located approximately 400 light-years away in the constellation Pegasus, this planet offers a glimpse into the bizarre possibilities of atmospheres beyond Earth's. The temperatures on WASP 76b soar to astonishing levels, reaching up to 2,800 degrees Celsius on the day side. This scorching heat creates an environment so relentless that metals like iron vaporize and ascend into the atmosphere. As night falls on WASP 76b, the situation takes an even more unsettling turn. The severe temperature gradient between the blistering day side and the cooler night side generates intense winds, which can reach astonishing speeds of several thousand kilometers per hour. These winds carry iron vapor from the heated side to the cooler regions, where it condenses into liquid droplets. What happens next is both fascinating and alarming. These droplets fall from the sky like iron rain. Picture a torrential downpour of molten metal, creating a truly nightmarish atmosphere. Furthermore, the planet's atmosphere is rich in other unusual compounds. Observations suggest the presence of heavy metals and various exotic molecules that contribute to the ferocity of the environment. The constant bombardment by winds and extreme temperatures leads to a dynamic weather system that is more chaotic than anything we experience on Earth. This relentless cycle of heat, vaporization, and precipitation creates an environment that would be hostile to any form of life as we know it. What emerges from the study of WASP 76b is a profound understanding of the diversity of planetary atmospheres throughout the universe. The existence of such extreme conditions challenges our conceptions of habitability and weather phenomena, reminding us that the cosmos is filled with unimaginable wonders and horrors alike. Our exploration of these distant worlds not only expands our knowledge of the universe, but also ignites our curiosity about the possibilities that lie beyond our own experience. The planet WASP 76b presents a fascinating yet hostile environment for scientists striving to understand its characteristics. This exoplanet, located over 600 light-years away in the constellation Pisces, is known for its extreme temperatures that swing from scorching hot during the daytime to significantly cooler at night. Such fluctuating temperatures lead to unique atmospheric phenomena that challenge our current methods of observation and analysis. During the day, temperatures on WASP 76b can soar to more than 2,500 degrees Celsius, hot enough to vaporize metals. In this fiery atmosphere, researchers might observe remarkable events such as iron vapor and other elements interacting in ways that defy expectations. However, the intense heat can make it difficult for telescopes and instrumentation to collect accurate data without being affected by thermal noise, which obscures valuable signals that scientists seek to analyze. At night, cooler temperatures allow for a different set of conditions, providing a contrasting backdrop for the planet's atmospheric behavior. This dichotomy adds layers of complexity to human efforts, as scientists must consider how these two extremes influence phenomena like cloud formation and chemical compositions. The stark temperature shifts can lead to dynamic weather patterns on the planet, which may change rapidly and unpredictably, complicating observational opportunities even further. To capture the comprehensive reality of WASP 76b, researchers employ a combination of ground-based and space-based observatories. Observing this exoplanet requires advanced technology designed expressly for extreme environments, along with innovative techniques to mitigate temperature-related challenges. Despite the obstacles presented by the extreme temperatures, the potential discoveries await scientists who continue to delve into the mysteries of this extraordinary world, giving humanity deeper insights into the nature of exoplanets beyond our solar system. GJ 3512b is a fascinating exoplanet located in the constellation Eridanus, notable for its unpredictable orbital behavior. This variability raises significant concerns about its atmospheric stability. The planet orbits a star that is much dimmer and cooler than our Sun, and with its unusual orbital mechanics, GJ 3512b does not follow a predictable path. This erratic motion can lead to drastic changes in the planet's climate and atmospheric conditions. Understanding the atmosphere of GJ 3512b is challenging due to these unpredictable movements. Such fluctuations can cause rapid shifts in temperature and pressure, which in turn affect the planet's ability to maintain a stable atmosphere. An atmosphere relies on consistent conditions to support processes like weather and climate regulation. When those conditions are in constant turmoil, the balance necessary for a stable atmosphere becomes precarious. For example, if the planet experiences extreme heating or cooling phases, it may lose significant amounts of gases essential for maintaining a protective atmosphere. Additionally, the gravitational interactions with surrounding celestial bodies may further exacerbate these instabilities. As GJ 3512b orbits its star, the gravitational pull can alter not just its path, but also the composition and density of its atmosphere. This interaction creates a cycle where changes in orbital position may lead to atmospheric depletion or the creation of inhospitable conditions for any potential life. Exploring the potential for habitability on planets like GJ 3512b is an exciting yet daunting task for astronomers. The unpredictability of its position adds layers of complexity to our understanding, sparking curiosity about how planetary atmospheres adapt or fail to adapt under such erratic circumstances. By studying these dynamics, scientists hope to gain insights that extend beyond this distant world, enhancing our knowledge of atmospheric science across the universe. The density of a planet's atmosphere plays a crucial role in determining the safety of explorers who venture into its environment. On planets with high gaseous density, explorers must be particularly mindful of the atmospheric pressure, which can vary significantly from what humans experience on Earth. A denser atmosphere often means greater pressure, which can lead to dangerous conditions. For instance, at extremely high pressures, the risk of decompression sickness increases dramatically, presenting a serious challenge for human physiology. Moreover, a dense atmosphere can contain a variety of chemical compositions that may be harmful or even toxic to human life. There are planets with atmospheres rich in gases such as ammonia or methane, which pose not only respiratory threats, but also combustion risks when exposed to oxygen. This necessitates advanced safety protocols, including specialized equipment designed to filter or neutralize harmful substances before explorers can proceed safely. The technology used for exploration needs to account for these potential hazards, ensuring that life support systems are robust enough to sustain human life in such foreign conditions. Visibility is another critical consideration influenced by atmospheric density. In atmospheres filled with particulate matter or opaque gases, explorers can be at risk of becoming disoriented or lost. This situation demands navigational equipment that can compensate for limited visibility, employing technology that allows explorers to understand their surroundings accurately. Expeditions must be meticulously planned, taking into account not just the present safety measures, but also the unpredictable nature of a planet's gaseous environment. The engineering of exploration vehicles must also incorporate adaptations for varying atmospheric densities. Structures need to withstand significant pressure differentials and maintain buoyancy if necessary. This involves ongoing research and development as scientists and engineers work to create habitats and transport systems that can thrive in the extreme conditions encountered on some of these distant worlds. Understanding the implications of atmospheric density is integral to the success of future missions and the safety of every explorer involved. WASP 107b, a peculiar exoplanet located approximately 20 million light-years away from Earth, possesses a composition that raises significant concerns regarding human visitation. This planet, classified as a hot Neptune, features a gas-heavy atmosphere primarily composed of hydrogen and helium, supplemented by various other elements and compounds. Such a structure implies extremely low density, suggesting that the planet may not only be shrouded in thick gases, but also have a relatively shallow layer of heavy elements. The atmospheric conditions on WASP 107b would pose immediate challenges for human survival. With temperatures soaring well above what we experience on Earth, often reaching extremes that could be harmful to human biology, the inhospitable climate creates a hostile environment. Additionally, the presence of potential chemical compounds within the atmosphere could lead to toxicity, further complicating any plans for human exploration or habitation. Another factor to consider is the lack of a solid surface. Approaching WASP 107b would be akin to traversing a vast, turbulent ocean of gas, making landings unfeasible. Human missions would require specially designed equipment capable of withstanding high pressures and unpredictable weather patterns, significantly increasing mission complexity and risk. The exploration of this distant world highlights the intriguing possibilities and profound challenges posed by gas giants. As we seek to broaden our understanding of exoplanets, the composition of WASP 107b serves as a reminder of the boundaries of human exploration amidst the vast cosmos. Radiation exposure presents significant challenges for astronauts venturing beyond Earth's protective atmosphere, particularly during missions to other planets, such as Mars. Unlike Earth, which is shielded from harmful cosmic rays and solar radiation by its magnetic field and atmosphere, other celestial bodies do not offer the same level of protection. This exposure can lead to various health risks, ranging from acute effects during a short exposure to severe long-term consequences from prolonged missions. The most immediate dangers posed by high radiation levels include acute radiation syndrome, which can cause symptoms such as nausea, vomiting, skin burns, and damage to internal organs. Beyond the immediate effects, chronic exposure to radiation can significantly increase the likelihood of developing cancer, as the high-energy particles can damage DNA and disrupt cellular function. Research indicates that even moderate levels of radiation over extended periods can affect immune function, making astronauts more susceptible to infections and illnesses. Furthermore, astronauts exposed to radiation can experience cognitive decline and changes in vision. These effects could jeopardize their ability to perform essential tasks, navigate spacecraft, and make critical decisions during their missions. Such risks necessitate the development of effective shielding technologies and mission planning strategies that minimize exposure, especially during solar flares when radiation levels can spike dramatically. As we venture further into space, addressing these risks becomes imperative. Solutions like specially designed habitats, protective gear, and careful timing of spacewalks have gained attention. Understanding radiation exposure's comprehensive impact is crucial for ensuring the health and safety of astronauts as they explore new frontiers in the cosmos. Kelt 12b is an exoplanet that challenges our understanding of atmospheric dynamics with its extraordinary conditions. This planet is categorized as a hot Jupiter, a type of gas giant that orbits very close to its star. The extreme temperatures can exceed 1,000 degrees Celsius, creating an atmosphere that is not only hot, but also subject to violent storms. These storms are fueled by fierce winds and an array of gaseous components that can include elements like sodium and potassium, which lend the atmosphere a unique and chaotic character. The atmospheric phenomena on Kelt 12b could lead to treacherous conditions that are extremely alien compared to anything found on Earth. The high temperatures might foster the formation of intense heat waves and thermal tides, which could result in rapid shifts in pressure. These pressure variations can create powerful storms, potentially featuring winds that exceed speeds known in any terrestrial tornado. Such atmospheric turmoil could constantly reshape the landscape of this gas giant. Additionally, the composition of Kelt 12b's atmosphere adds another layer of complexity. The presence of various compounds, including metals in gaseous forms, suggests that the weather on this planet could produce dazzling phenomena, such as metal clouds. This leads to the possibility of rain composed of molten metal, a phenomenon that could easily be considered treacherous. The combination of high temperatures and unique chemical reactions may yield conditions harmful to any hypothetical atmospheric life that could exist in such an extreme environment. Scientists study Kelt 12b not just to satisfy curiosity about distant worlds, but also to gain insights into exoplanet atmospheres and their evolution. Understanding these treacherous conditions can inform the broader field of planetary science and improve our knowledge about atmospheric dynamics anywhere in the universe. Exploring planets with dense atmospheres like Venus presents unique challenges that can instill fears and concerns among scientists and engineers. The thick atmosphere on such planets is predominantly composed of gases that create an extreme greenhouse effect, resulting in surface temperatures that can melt lead. This severe environment complicates any attempt to explore the surface or study the atmosphere, as instruments and rovers must be specially designed to withstand intense heat and pressure. The crushing atmospheric pressure on planets with dense atmospheres is another significant hurdle. At the surface of Venus, for example, the atmospheric pressure is more than 90 times that of Earth's at sea level. This immense force can easily damage equipment not specifically built for these conditions, raising questions about the reliability and durability of exploration technology. Even the smallest failure in equipment can lead to catastrophic loss of mission objectives. Furthermore, the dense atmosphere complicates communication with missions on the surface. The thick cloud cover can obscure visibility and distort signals, which hinders remote operations and data transmission. Scientists must devise innovative solutions to navigate these barriers, fostering anxiety about the potential for lost contact or incomplete data during critical exploration missions. These formidable challenges underscore the need for careful planning and engineering. Each new mission into such inhospitable environments must grapple with the fear that our current technology may not be advanced enough to gather the wealth of information hidden beneath those dense clouds. Despite these fears, the quest for knowledge pushes us forward, igniting a determination to explore and understand these unique worlds. The gravitational conditions on different celestial bodies present unique challenges and experiences for any explorer venturing beyond Earth. For instance, gravity affects everything from mobility to the physical health of astronauts. On a planet with weaker gravitational pull like Mars, explorers may find themselves leaping further than they could on Earth. This can result in a greater risk of falls and injuries. The unfamiliar movement patterns may also exhaust the body more quickly, as muscles that are not typically used so extensively in Earth's gravity are called into action. On the other hand, heavier gravitational fields, like those found on Jupiter's moons, present an entirely different set of circumstances. Explorers would find it much more difficult to move, and the immense gravitational stress could lead to physical strain or injury. The weight of equipment and any life support systems required would increase, complicating logistics and transportation. Astronauts must also consider the consequences of harder landings, which could be dangerous even with protective gear. Further complicating matters are the long-term effects of living in different gravity environments. Research shows that astronauts returning from prolonged stays in microgravity often experience muscle atrophy and bone density loss. Explorers on planets with lower gravity might face similar risks, but in the opposite direction, potentially dealing with overstressed muscles due to the adjustment to a new gravitational regime. Ultimately, these gravitational conditions significantly impact not just the immediate physical actions of explorers, but their long-term health and ability to conduct research. Each experience reshapes their bodies, making our understanding of human adaptability in diverse environments a subject of great importance as we push the boundaries of exploratory science. The surface of LHS 1140b presents an inhospitable environment that may provoke significant psychological challenges for any potential human exploration. With an atmosphere dominated by extreme temperatures and radiation levels far beyond what we experience on Earth, individuals exposed to such conditions would likely experience heightened stress and anxiety. The fact that this exoplanet orbits its star much closer than Earth does to the Sun results in blistering surface temperatures and an environment teeming with uncertainties. The stark contrast between human life on Earth and the severe conditions of LHS 1140b could lead to profound feelings of isolation and helplessness. Such extreme settings can contribute to a phenomenon known as environmental hyperarousal, where individuals become increasingly alert and unable to relax due to the constant threat posed by the surroundings. This psychological state could hinder cognitive function, making it challenging for explorers to make critical decisions under pressure or to collaborate effectively with fellow crew members. Moreover, being constantly aware of the precariousness of life in such a hostile environment could lead to feelings of despair or hopelessness. The inability to find comfort in familiar activities or surroundings would strip away essential aspects of human experience that contribute to emotional well-being. This sense of disconnection could exacerbate mental health issues, such as depression or anxiety disorders, significantly complicating long-term missions. Experiencing extreme environments not only tests physical limits, but also challenges the very fabric of human psychology. Awareness of these potential impacts emphasizes the need for comprehensive mental health support and preparatory training for future explorers who may venture to planets like LHS 1140b. Understanding these psychological implications is crucial for ensuring both productivity and well-being in the face of such daunting conditions. The discovery of 51 Pegasi b was revolutionary, marking the first detection of an exoplanet orbiting a sun-like star. It orbits its host star at a remarkably close distance, resulting in scorching temperatures that can exceed 1,000 degrees Celsius. This extreme heat presents significant challenges for any future explorers or robotic missions. First, the high temperatures can severely damage any spacecraft materials designed for exploration. Standard components, from structural materials to electronics, may not withstand prolonged exposure to such heat. Engineers would need to develop advanced heat-resistant technologies to protect both the explorers and their equipment from rapid degradation or complete failure upon arrival. Additionally, the environmental conditions on 51 Pegasi b are likely tumultuous, given its status as a gas giant. The intense heat may contribute to violent weather patterns, including powerful storms and high-speed winds. Such chaotic atmospheric conditions would pose safety risks not just during landing and surface exploration, but also during any potential atmospheric sampling missions. Space agencies would need to account for these factors in mission planning. Perhaps most compelling is the notion that any potential future missions would require innovative cooling systems to combat the heat. These technologies could safeguard equipment and ensure that explorations could be conducted efficiently. The unique challenges posed by 51 Pegasi b illuminate the broader significance of understanding distant worlds, reminding us how even the most advanced technology faces daunting trials in the cosmos. The unique rotation of certain planets significantly alters the experience of human visitors. For example, those exploring the gas giants or distant exoplanets with unusual spin rates would encounter a vastly different environment than on Earth. A planet that rotates slowly might have lengthy days and nights, creating extreme temperature variations. These conditions would challenge human adaptability and technology, as visitors would need to prepare for drastic shifts in heat when the sun shines and chilling cold when it leaves. Consider a planet like Venus, which has an incredibly slow rotation period, taking about 243 Earth days to complete one rotation. Visitors there would experience an extraordinarily prolonged day, followed by an equally extended night. The psychological effects of such a long cycle could be profound, possibly affecting sleep patterns and overall health. This extended exposure to the harsh atmosphere, which is predominantly carbon dioxide with clouds of sulfuric acid, would also necessitate specially designed habitats for survival. The rotational dynamics of these planets can also lead to intriguing weather phenomena. Fast-rotating planets like Jupiter are known for their striking, colorful bands of clouds and intense storms, such as the Great Red Spot, a storm larger than Earth itself. Visitors to such locations might witness breathtaking views and natural spectacles unavailable anywhere else, though they would also have to contend with the high-velocity winds and extreme atmospheric pressure that accompany these storms. Ultimately, the rotation of a planet shapes not only the environment, but also the interactions that humans might have with it. The unusual day-night cycle and the resulting climatic conditions would influence everything from exploration timelines to the design of spacesuits and habitats, ensuring that every journey to distant worlds presents unique challenges and awe-inspiring experiences. K218b, an intriguing exoplanet located approximately 135 light-years away from Earth, has captured the attention of scientists and space enthusiasts alike. While this planet resides within the habitable zone of its star, making it a prime candidate for the potential existence of life, there are unsettling characteristics about its atmosphere that raise serious questions about actual habitability. Recent studies have revealed the presence of aromatic compounds, which include molecules like dimethyl sulfide. While these compounds are often associated with biological processes on Earth, their mere existence does not guarantee that life can thrive there. Moreover, the discovery of an atmosphere primarily composed of hydrogen raises significant concerns. A dense hydrogen atmosphere might ensconce the planet in extreme pressure conditions that could be detrimental to carbon-based life forms. Temperature fluctuations too present challenges. K218b is thought to experience intense atmospheric pressure and varying climate extremes. These conditions can lead to an environment that, while potentially teeming with complex chemistry, could be inhospitable for life as we know it. The delicate balance of temperature, pressure, and chemical composition required to support life might not exist on this distant world. Additionally, the presence of clouds rich in methane and other gases could obscure the surface, making it difficult for any potential life forms to harness energy from their star, stifling photosynthetic processes that are so fundamental to life on Earth. As scientists continue to explore the mysteries of K218b, these atmospheric characteristics remind us that even within target zones for habitability, the complexities of environments on other planets can be daunting. The discovery of potential microbial life on distant planets, such as K218b, opens up thrilling prospects for scientific exploration, but also introduces significant risks for human adventurers. If life forms exist in this alien environment, they could possess unique biochemistries that are vastly different from what we recognize on Earth. This unfamiliarity presents several unknown dangers, primarily related to the potential for pathogens that may not only elude human immune defenses, but may also disrupt biological systems in unforeseen ways. Random microbial entities could harbor harmful properties, potentially producing substances that lead to adverse reactions in humans. These reactions might range from minor allergic responses to severe infections that current medicine cannot combat. Human explorers, equipped with the best of modern medicine, could still face a formidable challenge if confronted with novel pathogens. The evolution of microbe resistance and its unpredictable behavior in human bodies could have dire consequences when encountering these extraterrestrial life forms. Moreover, even if these microbes are non-pathogenic, they could still pose challenges. For instance, they might interact and interfere with human technology, such as life support systems, causing system failures or malfunctions that could jeopardize missions. Contamination of food and water supplies could also result from these microbes, leading to biosecurity risks that human explorers would need to navigate carefully. Thus, the significance of conducting thorough research and preparing contingencies before making contact with potential microbial entities on K218b cannot be overstated. Scientific protocols, protective gear, and rigorous containment measures must be part of the exploration plans to safeguard both the human explorers and the integrity of the alien ecosystem. The excitement of exploration must be balanced with the responsibility of ensuring we do not inadvertently unleash unknown dangers or disrupt a fragile extraterrestrial environment. The discovery of exoplanets like TOI 700d, located in a habitable zone, raises intriguing questions about the potential for life beyond our solar system. However, the presence of dark matter in its vicinity could introduce risks for future explorers. Dark matter is an elusive substance that interacts gravitationally but does not emit light or energy in any measurable way. While dark matter makes up a significant portion of the universe's mass, its influence can manifest in unexpected ways. For explorers venturing to TOI 700d, one primary concern would be the impact of dark matter on gravitational forces. If dark matter is unevenly distributed in the area, it could create gravitational anomalies that may affect spacecraft trajectories or lead to unpredictable orbital dynamics. Such challenges could complicate landing procedures, maneuvers, and even the entire mission's safety. Navigating through these gravitational variances might require advanced technology and careful planning. Moreover, dark matter may interact with regular matter in ways we have not yet comprehended. If dark matter influences the local environment on TOI 700d, it could affect atmospheric conditions or geological stability. For explorers, this uncertainty translates into potential hazards, such as exposure to extreme weather patterns or geological activity caused by dark matter-related phenomena. These unknowns would necessitate thorough research to devise strategic responses to ensure the safety of missions. While dark matter does not pose direct threats like radiation or extreme climate, Its enigmatic nature could lead to unforeseen complications in exploration. Understanding its implications will be crucial as scientists prepare for future missions. The more we learn about both dark matter and exoplanets, the more equipped we will be to tackle the challenges of exploring new worlds. Unforeseen geological phenomena, such as earthquakes, volcanic eruptions, and landslides, can have dramatic and sometimes devastating effects on human safety. Earthquakes occur when there is a sudden release of energy in the Earth's crust, leading to ground shaking that can destroy buildings, roads, and vital infrastructure. The Richter scale, which measures these events, shows that even moderately powerful quakes can lead to serious injury or loss of life, particularly in densely populated urban areas. Volcanic eruptions present another significant risk, often with little warning. When a volcano erupts, it can release lava flows, pyroclastic flows, ash clouds, and toxic gases, all of which can threaten local communities. For instance, the eruption of Mount St. Helens in 1980 erupted with a force that dramatically reshaped the landscape and had lasting effects on air quality and the climate. Communities downwind face not only direct threats from the eruption, but also long-term challenges due to ash fallout and potential disruptions to agriculture and water supplies. Landslides, typically triggered by heavy rainfall or seismic activity, can sweep down hillsides with little warning. These colossal shifts in earth and rock can bury homes and block roads, isolating communities. The risk is particularly heightened in regions with steep terrain or where human activity has destabilized the land. The impact of landslides can be devastating, often resulting in loss of life and the displacement of entire communities. Governments and scientists are constantly working to improve prediction techniques and implement better building codes to mitigate the impact of these geological events. While it is impossible to prevent such phenomena, increased awareness and preparedness can significantly enhance safety measures and provide communities with strategies to respond effectively when nature reveals its unpredictable side. Explorers traveling to the distant star system of BD plus 20°307 may face psychological challenges shaped by profound solitude and separation from Earth. Such isolation can alter an explorer's mental state, creating an environment that is both exhilarating and daunting. Without the regular comforts and interactions of daily life on Earth, individuals might experience feelings of loneliness, anxiety, and an overwhelming sense of disconnection from familiar human experiences. The vastness of space can induce a unique perspective on existence. Facing the silent expanse, explorers may grapple with existential thoughts about their place in the universe and the significance of their missions. This can lead to moments of deep introspection, but can also provoke feelings of unease as they become acutely aware of their vulnerability in an alien environment. Individuals may also experience what scientists refer to as space adaptation syndrome, where the unusual conditions of a distant world create psychological stress, affecting mood, cognition, and overall well-being. Moreover, the physical distance from Earth can amplify the impact of these psychological effects. The knowledge that help is light years away creates a sense of fragility, and any mental deterioration can feel more pronounced without immediate assistance or direct communication with loved ones. Those chosen for such missions would require not only strong technical skills, but also the emotional resilience to cope with these extended periods of isolation. Despite these challenges, there exists the potential for positive psychological effects as well. Explorers might develop a heightened sense of camaraderie with their fellow team members, bonding over shared experiences. Moreover, the encounter with the unknown can spark creativity and scientific breakthroughs, as the need to adapt and solve problems in new environments often leads to innovative thinking. The exploration of BD plus 20°307 could therefore be seen as both a personal and scientific journey, reshaping not only their understanding of the cosmos, but also their understanding of themselves. The Earth's most extreme environments present a multitude of challenges that significantly impact human life. In regions like the polar ice caps, where temperatures can plunge to below 32 degrees Fahrenheit, survival becomes a constant struggle against the elements. These conditions lead not only to frostbite and hypothermia, but also to the mental stresses associated with isolation and extreme weather. As climate change alters these habitats, the unpredictability of weather patterns further complicates life for those who inhabit them. Moving to arid regions, we encounter deserts that may experience temperatures soaring well above 100 degrees Fahrenheit during the day while plummeting at night. The lack of vegetation and fresh water sources creates a scarcity of essential resources, making sustenance a daunting task. In these environments, dehydration can quickly become life-threatening, and the inability to access clean water can result in severe health issues. The struggle for food and water can also catalyze conflict among communities, further complicating survival. Then there are the dangers posed by high-altitude regions, where the thinning atmosphere presents its own set of risks. Humans venturing into such heights may experience altitude sickness, which can lead to life-threatening conditions if not managed properly. The harsh wind and cold can also lead to altitude-related dangers, making exploration in these areas both physically and psychologically taxing. The unpredictable nature of natural disasters like earthquakes, volcanic eruptions, and floods adds another layer of risk. These events can obliterate infrastructure, rendering entire communities vulnerable and unprepared for the ensuing chaos. As people adapt to these perilous conditions, their resilience is met with ongoing environmental challenges, leaving a lasting impact on their ability to thrive in such settings. The prospect of space exploration brings with it a range of fears, and one of the most significant contributors to this anxiety is the intense atmospheric pressure faced by astronauts. While the vacuum of space is a stark contrast to Earth's environment, the conditions experienced during launch and re-entry introduce a world of pressure that can be psychologically daunting. As rockets ascend through the atmosphere, astronauts are subject to forces far greater than what they experience on the ground. This sudden shift can instill a sense of vulnerability as they confront the reality of being in a metal capsule, hurtling upward at extremely high speeds. Imagine being enclosed in a space where every breath is monitored and controlled. The knowledge that a breach in the spacecraft's integrity could lead to catastrophic consequences heightens their awareness of potential dangers. The fear of failing to adapt to these extreme conditions can linger in the minds of many could-be astronauts. After all, years of rigorous training cannot entirely assuage a natural instinct to fear the unknown, particularly in an environment where survival is continually at stake. The notion of being exposed to pressures that could literally crush them or lead to oxygen deprivation becomes a source of stress that is hard to ignore. Moreover, the psychological pressure of isolation plays a role. Confined in a small space with limited mobility and interaction for extended periods can amplify feelings of anxiety. Astronauts are required to maintain peak performance amid overwhelming stress, and the fear that they may falter under that pressure can be unsettling. The knowledge that they are responsible not only for their well-being, but also for the safety of their crew adds another layer of psychological burden. As astronauts prepare for missions, they must confront these fears and find ways to navigate them. Embracing a robust training regimen and relying on teamwork can help build resilience in the face of adversity. Yet despite preparations, the reality of space travel encompasses inherent risks that tap into our deepest fears of the unknown. Consequently, this blend of intense atmospheric pressure and psychological challenges creates a complex landscape that potential astronauts must traverse on their journey to reach the stars. K2-141b, a super-Earth located over 200 light-years away from our planet, presents formidable challenges for communication. This exoplanet orbits a distant star, and its extreme conditions make any potential human exploration especially risky. The vast distance itself imposes a significant communication delay. Signals traveling at the speed of light, the fastest speed in the universe, would take over 200 years to reach us from this planet. This lengthy delay creates a disconnect that could have dire implications for those who might venture there. In a high-risk environment like that of K2-141b, where temperatures soar to scorching extremes and the atmosphere is inhospitable, timely communication becomes critical for survival. Should explorers experience any emergencies or unexpected challenges, The inability to receive immediate support or guidance could drastically reduce their chances of survival. Every moment counts in a perilous situation, and one could only imagine the potential consequences of waiting decades for assistance or resolution to a crisis. Moreover, the risks associated with the constant communication challenges are compounded by the nature of K2-141b's environment. With its extreme temperatures and possible volcanic activity, conditions could change from manageable to life-threatening in seconds. The complexity and unpredictability of these conditions require instantaneous decision-making and swift action, something that a delayed communication system cannot provide. This reality emphasizes the importance of developing advanced autonomous systems capable of operating independently, mitigating the risks tied to human limitations of distance and time. It beckons the question of how we might prepare for such distant explorations, where every second without support could be the difference between life and death. As we delve deeper into the possibilities of life beyond our own, the challenges of communication on distant worlds like K2-141b remind us of the hurdles that still remain. WASP-43b, an exoplanet located about 39 light-years away, presents a unique and hazardous environment, particularly in terms of electrical activity. This planet is classified as a hot Jupiter, meaning it is a gas giant with a close orbit around its star, resulting in extremely high temperatures that can reach over 1,000 degrees Celsius. These conditions are not only hostile to potential exploration missions, but also create an extreme atmospheric environment that fosters significant electrical phenomena. The intense heat contributes to the creation of strong storms in WASP-43b's atmosphere, which can generate spectacular lightning activity. The combination of rapid atmospheric dynamics and high temperatures leads to energetic electrical discharge, akin to the severe weather systems we observe on Earth, but on a much more violent scale. The lightning on this planet can release enormous amounts of energy, creating a perilous setting for spacecraft that may attempt to study it. Such discharges can damage sensitive instruments, disrupt communication systems, and pose risks to the overall integrity of exploration missions. Moreover, the planet's atmosphere is rich in various compounds that could further complicate electrical activity. Scientists believe that the presence of elements such as sodium, potassium, and water vapor plays a critical role in the chemical and electrical interactions within the atmosphere. These interactions can lead to unpredictable weather patterns, making it challenging to ascertain safe windows for exploration or landing. Consequently, any mission sent to WASP-43b must be equipped to withstand not only the harsh temperatures, but also the ongoing and dynamic electrical storms. Exploration of such extreme environments raises substantial challenges for scientists and engineers. Given the intense electrical activity, any exploratory instruments must be designed to endure potential lightning strikes and electromagnetic disturbances. Providing adequate protection and ensuring reliable operation in this tumultuous atmosphere remains a significant engineering hurdle in the quest to understand WASP-43b and its intriguing weather patterns. As scientists continue to examine the complexities of this distant world, they hope to unlock the secrets that lie within its electric storms. Astronauts studying exoplanets like WASP-43b face extreme conditions both during their training and while undertaking missions that involve intensive research on distant worlds. The journey to understanding these astronomical phenomena takes place in settings that require astronauts to endure isolation, confinement, and a constant barrage of unfamiliar stimuli. These stressors can create formidable psychological barriers which impact their focus, decision-making abilities, and overall mental health. For example, the distance from Earth, often measured in light years, compounds feelings of separation and detachment. On their missions, astronauts find themselves subjected to sensory deprivation, unable to experience the normalcy of life on Earth. This experience is akin to living in a very small underwater habitat or a sealed environment for extended periods. It can lead to feelings of claustrophobia and vulnerability. The harsh conditions of space amplify these effects, making even minor disagreements or stresses feel monumental in such isolation. Moreover, the conditions on planets like WASP-43b which is classified as a hot Jupiter, lead to extreme temperatures and atmospheric pressure that are unimaginable on Earth. While astronauts may not physically visit these harsh worlds, their studies rely heavily on simulations and data analysis under pressure. The pressure to yield significant scientific results can exacerbate existing mental strain, leading to anxiety and burnout. An astronaut may become hyper-aware of their own vulnerabilities, which complicates team dynamics and productivity. Understanding these psychological barriers is crucial for mission planners. It is essential to provide astronauts with the necessary tools and strategies to cope with these extreme stresses. Developing robust support systems, including psychological evaluations and team-building exercises during training, can help mitigate the psychological impact. Ensuring that astronauts have a strong support network can enhance their resilience and improve the quality of their research, which is vital for our quest to uncover the mysteries of the universe. PSR B 1257+12b, an intriguing planet orbiting a pulsar, presents a unique challenge for human exploration due to its formidable radiation environment. Pulsars are remnants of massive stars that have undergone supernova explosions, resulting in highly magnetized rotating neutron stars. As these stars spin, they emit beams of intense radiation, including gamma rays and X-rays. For PSR B 1257+12b, the presence of such strong radiation levels creates significant barriers for any potential human missions. The constant bombardment of high-energy particles means that the planet's surface is far from a safe haven for human explorers. Without protective shielding or advanced technologies to mitigate radiation exposure, the health risks for astronauts would be excessively high. Long-term exposure to radiation is known to increase the likelihood of cancer, damage to the central nervous system, and other grave health issues. Thus, any plans to explore this planet would require comprehensive strategies to safeguard human life against the relentless radiation. Moreover, this intense radiation environment may limit the duration of any potential exploration missions. Astronauts would need to rely on specialized equipment and habitats designed to withstand or deflect radiation. This means that significant advancements in technology would be essential before even considering a human venture to PSR B 1257+12b. As we ponder the prospects of exploring distant worlds, PSR B 1257+12b serves as a stark reminder of the challenges awaiting us beyond our own pale blue dot. The lessons gleaned from studying this pulsar and its planetary system enrich our understanding of cosmic hazards, ultimately paving the way for safer exploration of the universe. On this unusual planet, one of the most startling geological activities is the presence of supervolcanoes. These massive volcanic systems can erupt with a ferocity that is incomprehensible to most. When a supervolcano erupts, it has the potential to release vast amounts of ash and gas into the atmosphere, triggering climate shifts and altering ecosystems for years. The size of these eruptions can dwarf the more familiar volcanic explosions we see on Earth, affecting weather patterns around the globe. Another fascinating aspect of this planet's geology is the presence of extreme tectonic activity. The shifting of tectonic plates can lead to frequent and powerful earthquakes, which may reshape the landscape in an instant. This geological instability suggests an active interior, perhaps fueled by the heat from a molten core. Such conditions create a hazardous environment for any potential life forms or human endeavors. Landslides and mudflows are also common due to the frequent seismic activity. The landscape can change dramatically in a short period, presenting significant challenges to exploration. Erosion can rapidly alter ground structures, leading to risks for any inhabitants or explorers on the surface. These events remind us that although there may be beauty in the stark landscapes, they are also marked by danger. Lastly, the unusual features of the planet's surface may indicate a history of different geological processes at play, possibly linked to its unique atmosphere or cosmic conditions. Understanding these geological dangers is crucial not only for those who might wish to explore this world, but also for scientists seeking to understand the broader implications of planetary geology across the universe. The planet's history is marked by moments of darkness and turbulence that have shaped human perception and emotion. From catastrophic natural disasters, such as volcanoes erupting and hurricanes devastating coastlines, to the long, cold nights of ice ages, these events have left a lasting imprint on our collective psyche. Humans have always been keen observers of nature, and when faced with unpredictable and extreme weather, it is only natural that fear emerges. This deep-seated anxiety can be traced back to our ancestors who relied on their ability to interpret the environment for survival. Extreme weather acts as a reminder of nature's raw power and unpredictability. Events like droughts can lead to the fear of food scarcity, while floods can obliterate entire communities, creating a sense of vulnerability. This fear is compounded by the awareness that these natural forces are often beyond human control, driving home the point that despite our technological advancements, we remain mere guests in a world governed by nature. Such realities underscore our existential anxieties and fuel fears of potential calamities, which can lead to a longing for predictability and security. Moreover, the dark history of our planet serves as a backdrop for many contemporary fears. The remnants of past mass extinctions and the environmental consequences they brought echo in current ecological crises. Climate change, a product of historical exploitation of Earth's resources, is now at the forefront of global concerns. This leads to widespread dread about the future, prompting individuals to grapple with fears about not only their immediate surroundings, but also the legacy they may leave for future generations. As discussions around climate change intensify, they often stir up emotions rooted in our darkest historical chapters. The interplay between extreme weather patterns and humanity's fears is palpable in environmental discourse today. When catastrophic events occur, they serve as both a warning and a call to action, igniting old fears while inviting society to harness those emotions toward meaningful change. Such dynamics reveal how our understanding of the planet's past continues to shape the narratives we tell ourselves about the future. The size of a planet and its rapid orbit around its star significantly influence the environmental conditions that can be found on its surface. For instance, planets that are smaller in size tend to have less gravitational pull, which can affect their atmospheric retention. This means that if a planet orbits very close to its star, it risks losing its atmosphere entirely, exposing its surface to extreme temperatures and harmful radiation. When a planet completes an orbit in a short time frame, it experiences intense heating from its host star. This can lead to sweltering days and frigid nights if the planet has a slow rotation. If the orbit is exceptionally quick, the temperature fluctuations can become severe, creating conditions that may be far more extreme than anything on Earth. As the star's rays blast down on the surface, any atmosphere present may struggle to mitigate these extreme conditions, leading to toxic winds or deadly storms. Additionally, a fast orbit can lead to tidal locking, where one side of the planet permanently faces the star. The continuously exposed side becomes scorched, while the perpetually dark side could plunge into freezing temperatures. This stark contrast could create chaotic weather patterns in the twilight zone that separates the two extremes. Variability in these conditions leads not only to temperature extremes, but also to unpredictable weather phenomena. On planets found in such hostile environments, life, if it exists, would need to adapt to astonishingly harsh realities. These adaptations might include extraordinary resilience to temperature changes or mechanisms to endure harsh radiation. The interplay between a planet's size, orbit, and proximity to its star results in a tantalizing mix of possibilities, showcasing just how diverse and extreme planetary conditions can be across the universe. The exoplanet HD 80606b presents a fascinating example of extreme weather. Orbiting its star at a distance that allows for intensely varied temperatures, this gas giant undergoes dramatic atmospheric shifts. Its orbit is highly eccentric, meaning it spends a significant amount of its orbit close to its star, experiencing blistering heat, and then moves far away, where it cools down substantially. During its closest approach, surface temperatures can soar, reaching over 1,000 degrees Celsius. This extreme heating leads to the development of powerful winds and storms. If humans were somehow exposed to the conditions on HD 80606b, they would enter an environment hostile to life as we know it. The air, largely composed of hydrogen and helium, would not support respiration. The extreme heat, coupled with violent storms that can whip through the atmosphere at thousands of kilometers per hour, would make survival utterly impossible. Imagine being caught in a tempest of such ferocity. The atmosphere would feel more like a boiling cauldron than a breathable space. The planet experiences swift and radical changes in weather patterns. As the planet moves away from its star, the temperature plummets, creating a cold that would seem unimaginable to human sensibilities. The sudden transition from scorching heat to frigid conditions might produce intense waves of turbulence in the atmosphere, akin to massive, swirling clouds. This volatile weather may even lead to phenomena reminiscent of hurricanes, only on a far grander and more destructive scale. Life on HD 80606b would flourish in ways completely alien to us, yet humans remain susceptible to the allure of understanding such wildly diverse environments. The study of such extreme weather not only expands our knowledge of planetary science, but also raises questions about the resilience and adaptability of life in the universe. Understanding these conditions, even from a distance, enhances our appreciation of both our own planet's stability and the limits of human endurance. Fierce winds and storms present significant challenges to human survival on Earth, influencing both immediate safety and long-term living conditions. When storms unleash their fury, they can unleash powerful gusts that not only cause physical destruction to infrastructure, but also create hazardous conditions such as floods and landslides. These events can lead to loss of life, displacement of communities, and the destruction of vital resources, making recovery difficult. Wind patterns play a crucial role in climate and weather systems. For instance, hurricanes and typhoons fueled by warm ocean waters can produce winds that reach extraordinary speeds, often exceeding 150 miles per hour. The combination of high winds and heavy rainfall can lead to catastrophic flooding, overwhelming rivers and drainage systems. These storms serve as stark reminders of nature's unpredictability, forcing communities to adapt and find ways to protect themselves. Furthermore, the impact of storms extends beyond immediate physical dangers. In the aftermath of fierce winds, infrastructure damage can disrupt essential services such as electricity, water, and communication systems. This lack of basic necessities can lead to public health crises, as clean drinking water may be compromised. Communities often face immense economic burdens in rebuilding efforts, which can take months or even years, creating a lasting ripple effect on their resilience. As climate change progresses, scientists warn of increases in storm frequency and intensity. This shift poses even greater challenges for human survival. Adapting to these changes requires innovative solutions, from improved building designs that can withstand high winds to better emergency preparedness plans. Acknowledging the fierce winds and storms as integral elements of our planet is essential if humanity hopes to thrive in the face of such tremendous natural forces. WASP-31b presents a hostile environment that would pose significant risks to any potential human explorers. This exoplanet is classified as a hot Jupiter, meaning it is gas giant orbiting close to its star, resulting in extreme temperatures. The atmosphere experiences relentless heat, with surface temperatures soaring well beyond what human beings could withstand. The scorching conditions alone create an environment that would be uninhabitable without advanced protective technology. Beyond the intense heat, the atmospheric composition of WASP-31b contributes to its inhospitable nature. The planet's atmosphere is likely filled with thick clouds of gas, primarily composed of hydrogen and helium. This dense atmosphere would inhibit visibility, making navigation and exploration incredibly challenging. Moreover, the presence of various chemicals in the atmosphere could pose toxic risks, adding an additional layer of danger for humans who might try to venture there without proper safeguards. WASP-31b is also subjected to fierce storm systems. These violent weather patterns can be a product of the extreme heat and rapid wind velocities that characterize such gas giant planets. The storms on WASP-31b could involve winds that reach staggering speeds, potentially exceeding several hundred kilometers per hour. These fierce winds could create hazardous flying debris and unpredictable turbulence, making any attempt at aerial exploration perilous. Given the combination of extreme temperatures, a potentially toxic atmosphere, and violent weather, the environment of WASP-31b is daunting. Human explorers would face formidable challenges simply to survive, let alone ensure effective exploration. It is a reminder of how diverse and extreme planetary environments within our universe can be, where conditions differ drastically from Earth and necessitate careful consideration when contemplating future exploratory missions. WASP-31b, an exoplanet residing over 300 light-years away, has caught the attention of astronomers and chemists alike with its unique atmospheric features. This gas giant, which is considerably larger than Jupiter, challenges our understanding of planetary formation and composition. The mysterious chemical signatures detected in its atmosphere raise genuine concerns among scientists who strive to comprehend the complexities of such a foreign environment. When researchers analyze the atmospheric components of WASP-31b, they encounter unexpected elements and compounds that have profound implications for our theories of planetary chemistry. These findings can ignite fears because unexplained anomalies in chemical compositions might suggest that our models of planetary behavior are not as robust as previously believed. Each new piece of data could potentially defy existing scientific paradigms, leading to a cascade of questions about what constitutes a habitable environment or how life could arise elsewhere in the universe. Moreover, the extremes in temperature and pressure on WASP-31b sustain a volatile atmosphere filled with exotic compounds. Scientists worry that if their models do not accurately predict the behavior of these chemicals under harsh conditions, it could hinder their ability to discover viable exoplanets that might host life. The haunting fear persists that the more we learn about distant worlds like WASP-31b, the more elusive the answers to fundamental questions about life's potential beyond Earth may become. Facing these uncertainties requires an openness to rethink existing assumptions about planetary systems. It highlights the importance of collaboration as researchers from varying fields come together to build a comprehensive understanding of chemical environments in the cosmos. As we delve deeper into the mysteries presented by celestial bodies like WASP-31b, the pursuit of knowledge also reveals the inherent complexities that accompany our quest to comprehend the universe. The exoplanet known as WISE 850714b presents a chilling portrait of an icy world, where temperatures plunge to levels that would be intolerable for any known form of life. With surface temperatures estimated to be around -270 degrees Celsius, the environment is not just cold, it is a realm of perpetual frost and frozen gas. This extreme cold reshapes the very fabric of the atmosphere, creating conditions that are both hostile and haunting. Visitors to WISE 8507. 14b would encounter not only frigid temperatures but also the presence of thick clouds composed of various icy compounds. Such clouds serve to shroud the planet in a dense atmospheric veil which could obscure visibility significantly. The feeling of isolation would be profound as the bone-chilling winds sweep through a barren landscape, lending an eerie silence to this alien world. The kind of cold that exists here is not simply a numbing chill, it can freeze any exposed water instantly, solidifying any matter that might unintentionally come into contact with it. Moreover, this extreme cold conditions the air, adding another layer to the menacing atmosphere. The presence of frost or ice crystals can create a mystifying sight, yet they also signal an absence of warmth and life as we understand it. The very nature of such an environment is one of desolation, evoking a sense of foreboding for any adventurer daring enough to contemplate a journey there. The chilling reality of survival becomes paramount, as the lack of thermal energy means that even the most advanced technology available would face significant challenges against the icy grip of this distant planet. The combination of oppressive cold, thick, obscuring clouds, and the haunting silence gives WISE 850714b a profoundly unsettling atmosphere. It is a world that triggers the imagination, evoking images of alien landscapes that defy the warmth of life. For those intrigued by the cosmos, this extreme cold is not merely a meteorological phenomenon, but a stark reminder of the universe's capacity for extremes. The absence of sunlight presents profound challenges that can significantly impact human endeavors, influencing everything from agriculture to energy production. Without the warm rays of the sun, the growth of crops would be severely hindered. Sunlight is essential for photosynthesis, the process through which plants convert light energy into chemical energy. A world devoid of sunlight would lead to widespread crop failures, food shortages, and ultimately threaten global food security. With most of our agricultural systems relying heavily on the sun, the disruption could trigger severe economic repercussions, particularly in regions dependent on farming. Energy production would also suffer tremendously. Currently, renewable energy sources like solar power are becoming indispensable in our efforts to reduce carbon emissions and combat climate change. A lack of sunlight would eliminate the potential for solar energy generation, forcing societies to rely more heavily on fossil fuels or other non-renewable resources. This shift could exacerbate environmental degradation and escalate the struggle for energy security. The resulting increase in energy costs may further create economic strain on households and businesses alike. Moreover, beyond the practical consequences, the absence of natural light could take a toll on human health and well-being. Sunlight plays a critical role in regulating our circadian rhythms, influencing sleep patterns and hormone levels. Prolonged darkness could lead to increased incidences of anxiety, depression, and other mental health issues. The lack of sunlight would limit our ability to engage in outdoor activities, depriving us of essential physical exercise and the social connections that come from communal outdoor experiences. Finally, the cultural implications cannot be overlooked. Human societies have long celebrated the sun, viewing it as a source of life and inspiration. Festivals that honor sunlight and its vital contributions to nature and human culture would be relegated to memory. In an ever-dark world, humanity would have to seek new ways to adapt and find meaning, sparking transformations in our rituals, traditions, and connections to the natural world. The challenges brought about by a lack of sunlight would reach deep into the fabric of human existence, prompting us to rethink our relationship with energy, health, and our environment. Teagardens Star B, an exoplanet located about 12.5 light-years from Earth, has piqued the interest of astronomers and scientists alike due to its proximity and potential habitability. However, significant challenges arise when considering the implications of its resource scarcity for any human exploration missions. The lack of essential resources such as water and suitable atmosphere raises critical questions about the viability of sustaining human life on this distant world. Scientists have identified that upon initial observations, Teagardens Star B has limited information regarding its atmospheric composition. Without a rich atmosphere or sufficient water resources, explorers would face considerable hurdles in establishing any form of long-term habitation. Humans require water not only for hydration, but also for agriculture and various life support systems. The absence of these vital elements would demand that explorative missions find alternative means to generate sustenance in an environment devoid of natural resources. Furthermore, exploring this distant planet without available resources poses an enormous logistical challenge. Astronauts would need to carry all the necessary provisions from Earth. This would greatly increase the costs and complexity of missions. Every aspect of life support, from food to clean air, would need to be meticulously planned and transported, making exploration more akin to an extended expedition rather than a sustainable colonization effort. The implications extend beyond physical survival. The emotional and psychological strain of being isolated in an environment lacking resources could take a toll on the mental well-being of the crew. Missions to Teagardens Star B would not only require robust physical preparation, but also strong psychological support systems to ensure the crew remains resilient in the face of potentially overwhelming challenges. The exploration of such distant worlds uncovers not just scientific opportunities, but also tests the limits of human endurance and ingenuity. As explorers set foot on celestial bodies, they often encounter a profound silence that can evoke feelings of unease. This silence, especially pronounced on planets and moons lacking atmospheres, transforms environments into otherworldly landscapes. For scientists accustomed to the rich symphony of sounds on Earth, the stark absence of noise can underscore a sense of isolation and vulnerability in the vastness of space. The eerie quietness serves as a reflection of the atmospheric conditions of these celestial terrains. On Earth, sound travels through air and water, carrying with it the vibrations of life. When standing on a barren surface like that of the Moon or Mars, everything changes. The normal sounds of wind, animals, and even rustling leaves are replaced by an almost haunting stillness. This absence can heighten awareness of one's surroundings, intensifying feelings of insignificance against the backdrop of the infinite cosmos. Moreover, the silence can trigger feelings of anxiety as it forces explorers and scientists to confront the realities of extraterrestrial environments. With no familiar sounds to reassure them, they are left solely with their thoughts. For many, the quiet invokes the notion of danger. What else might be lurking in this expansive emptiness? The mind races with questions, as the silence becomes a canvas upon which fears and uncertainties can easily be painted. Ultimately, the unsettling nature of this silence speaks to a deeper exploration of existence itself. It challenges individuals to reconcile their understanding of life, communication, and connection with the overwhelming vastness of the universe. Each whispered hypothesis or cautious step taken on these alien landscapes compels scientists and explorers to keep pushing boundaries, even while grappling with the solitude that envelops them. Upsilon Andromedae D resides in a hostile environment that presents several chilling characteristics, significantly complicating the prospects for human exploration. First and foremost, this exoplanet lies within a binary star system, which means it experiences a complex interplay of gravitational forces not found in our own solar system. Such a dynamic can lead to extreme fluctuations in temperature, as the planet may face substantial heating from dual stellar sources, while also suffering from prolonged periods of darkness. Another alarming characteristic is the planet's atmosphere, which is likely thick and comprises primarily of hydrogen and helium. This composition creates a high-pressure environment that would be lethal for human beings without substantial life support systems. The atmospheric conditions, combined with potential violent weather patterns, including powerful storms or intense radiation from the nearby stars, could make surface exploration dangerously unpredictable. The gravitational pull on Upsilon Andromedae D is another concern. Depending on its mass and size, the planet's gravity might be significantly stronger or weaker than what we experience on Earth. Such a variation would impose challenges for human physiology, impacting muscle and bone structure over time. Adapting to these gravitational dynamics while also ensuring the safety and health of individuals remains a monumental hurdle for any exploration mission. Lastly, the proximity of this exoplanet to its stars may lead to heightened levels of radiation, especially if it lacks a protective magnetic field or atmosphere capable of shielding life from harmful cosmic rays. These radiation levels could prove disastrous for human explorers, increasing the risk of cancer and other health issues. Each of these factors reminds us how extreme and diverse conditions can be in the universe, as well as the significant obstacles we face in our quest to explore beyond our own world. The immense scale of the cosmos can have profound psychological effects on individuals tasked with exploring distant planets. For astronauts visiting a planet like Mars, the sheer isolation of space can foster feelings of vulnerability. When surrounded by an infinite expanse, thoughts can drift to the enormity of the universe, leading to a sense of existential dread. The intimidation of vast distances, the knowledge that Earth is millions of kilometers away, and the unpredictability of life in space can induce anxiety and fear. Moreover, the environment of a distant planet itself presents numerous challenges. The stark, barren landscapes devoid of life can amplify feelings of loneliness. When astronauts step onto a planet with red dust stretching as far as the eye can see, the realization that they are far from home and immersed in the unknown can be unsettling. This desolation tends to magnify their emotional state, leading to heightened awareness of their own fragility in an unforgiving universe. The psychological impact is further complicated by confinement in a tight space for prolonged durations. Life in a spacecraft or planetary habitat often requires teamwork and close collaboration. However, such intimacy can lead to interpersonal conflicts, which are exacerbated by the isolation and stress of the mission. For astronauts, the psychological strain of managing their emotions while maintaining a sense of camaraderie adds another layer to their experience of fear, as they must rely on each other in an environment where help from Earth may not be immediately available. Astrophysicists and psychologists recognize that these feelings are not merely the result of individual temperament, but are deeply rooted in the human experience. The exploration of other planets is as much a psychological journey as it is a physical one. Understanding this complexity is essential for preparing astronauts and ensuring their mental well-being during these groundbreaking missions into the great unknown. Rho Ophiuchi b is a fascinating exoplanet located within a stellar system about 40 light-years away from Earth. It orbits a binary star system, which means it is subject to different gravitational forces and radiation levels than what we experience in our solar system. For potential explorers considering missions to distant planets like Rho Ophiuchi b, the idea of cosmic threats often looms large in their minds. The uncertainty regarding unknown hazards, such as intense radiation from its nearby stars or potential impacts from space debris, heightens these fears. The exploration of distant worlds is fraught with unknowns. For example, Rho Ophiuchi b exists within a region of space that is still less understood. Scientists have mapped out many celestial bodies and their orbits, yet there are still gaps in our knowledge about the dynamics of these systems. This lack of complete information can evoke anxiety, as the risks involved in traveling to such remote locations become difficult to quantify or predict. When considering a mission to Rho Ophiuchi b, scientists must analyze not just the physical terrain, but also atmospheric conditions, temperature fluctuations, and the potential for catastrophic events. Moreover, there is an inherent fear of the unknown. Space exploration has historically been a field marked by surprises. For every successful mission, there have been stories of equipment failures, unexpected environmental conditions, and even loss of life. The possibility that Rho Ophiuchi b could harbor invisible threats, such as toxic gases or hostile conditions, adds a layer of complexity and unease to these missions. This becomes even more pronounced when we consider the psychological impacts of isolation and confinement in space, which can amplify fears of encountering unforeseen dangers. The combination of these factors, the intimidating distances, the unpredictable environment of distant worlds, and the psychological aspects of exploration, creates a landscape fraught with anxiety for those tasked with contemplating missions to places like Rho Ophiuchi b. While the prospect of new discoveries drives many forward, the potential for unseen threats is a very real consideration in the realm of cosmic exploration. This duality of wonder and fear illustrates the delicate balance explorers must navigate when charting the unknown waters of our universe. Navigating around the myriad star systems surrounding Rho Ophiuchi b presents significant coordinative challenges for human explorers. With Rho Ophiuchi b being part of a complex network of stars, the first hurdle is the sheer density of celestial bodies. Each star system has its own gravity, which creates intricate gravitational fields. As they approach these bodies, explorers must constantly adjust their trajectories to avoid being pulled off course, making every maneuver crucial and high stakes. The varying distances between these star systems complicate navigation further. Some may be light years apart, while others appear much closer due to irregular spatial configurations. This requires precise calculations and real-time adjustments. Astronauts would need to rely on advanced navigation systems and artificial intelligence to track their position, speed, and the trajectory of surrounding celestial objects to avoid potential collisions. The challenge is amplified by the fact that these systems might also host their own planets and debris, adding layers of obstacles for the explorers to navigate. Communication delays pose another hurdle. Even with advanced technology, signals take time to travel across vast interstellar distances. This means that by the time a crew receives new coordinates or navigational guidance from Earth or their base, they may already be significantly off course. Such delays could lead to a dangerous series of decisions made on outdated information, forcing the crew to rely more on their instincts and quick problem-solving skills. Additionally, the psychological tension among the crew is likely to rise as they grapple with these overwhelming challenges. The profound uncertainty of the navigational landscape can induce anxiety, testing the crew's teamwork and resilience. Each successful navigation around a star system might be a small victory, but the constant pressure not to make a critical error can weigh heavily on human minds, adding a layer of complexity to the already complicated task of exploration. Such factors are a testament to the intricate dance of human innovation and the formidable power of the universe, showcasing both the brilliance and vulnerability of human endeavors in the cosmos.